we will have a look on this, what is called in English, I believe it's called a form tester. It's MahrMMQ100. I mean, you will tell us more precisely, but this device should be for detecting and checking some geometrical tolerances like smoothness, cylindricity, and also roundness, and also this, what is flatness, yes, is it so? Okay, anyway, please take over. We have scheduled to be here kind of full day until 5 o'clock Estonian time. We will make some pauses. There is, yes, definitely some lunch and something else. And we will try to work in a way that you will guide us through the camera eye. I hope it will work.
Yeah.
Okay.
Should work.
Yes.
So first of all, the MMQ100 is entering the form measuring system. So it's the smallest system we have available, and it's more like stand for or mounting device for a probe that is touching the part around and measuring things like roundness and so on. This means for the form measurement in general, the absolute position is not really important. Means you cannot measure something like distances or diameter with the form tester, because the absolute position of the probe relative to the part is mostly unknown, or in this case, let's say with very high tolerances. So these values you can just evaluate them, but I would not rely on them. So yeah, and then we have first we have our machine with the axis. We have the z-axis, which is going up and down.
Yes, sorry, I will show them on the screen also. So this will be the z-axis of the machine.
Yes.
Yes.
And then we will have the x-axis, and the c-axis is the main axis of the machine, because this is the reference for everything else. Means that the c-axis, the turning axis of the workpiece, is the reference for everything else. Means that the z-axis should be parallel and the x-axis should be perpendicular to the workpiece axis, to the c-axis of the machine.
Okay. So just let me show you to the students that c-axis. C is the rotational axis of this table. Is it so?
Yes, that's right.
Okay.
So means if you move it, then the machine will just turn, and
yes.
So this is the c-axis.
Okay.
So, and on the machine, on the table, you have 4 axes on the table. These axes are called X, Y, A, and B.
There is your X.
X, yes.
And there is the Y.
Y. And then we have A and B.
And B, yes.
So these axes are two two linear axes and two rotational axes to align the workpiece axis to the c-axis of the machine.
Okay, so it means, yes, we can, in principle, we can shift. Let's say if we have this part right now, it's a cylindrical part, it has an axis, and when we need to align the axis of the part to the axis of the machine, we can move it linearly, I think, in 2 directions.
Yes.
That is your X and Y, yes.
Yes.
And then we can also tilt it.
Yes, exactly.
So tilt it also to be collinear with the c-axis of the machine.
Exactly.
Okay, and for that we have A and B.
A and B, yes.
Yes.
And in complete, the table is usually called a centering and tilting table.
Okay.
So good. Yeah, this is the hardware. Good. We have our software. This software is called EasyForm. And on the screen, you will find a button. If you find it between all these buttons, icons.
Programs, MahrMMQ100, connect the machine, switch on the machine. Let's see what will happen. So there is a side button here on the machine where we could switch it on. Let me see. All the cables should be connected. And let's try to, the camera. Let's try to execute the program EasyForm one more time. Yes, looks much better.
Okay.
So I think we have managed to start it. Let's take user Tonu. That is me.
Yeah. Good.
Yes.
So this is the starting. Please check the current position of the axis. That means because the machine doesn't really know where it is, so you have scales at the axis to move the probe and the axis to the right position.
Okay. So sorry, in between we have been positioning the camera, so that's why the picture has been.
Yeah.
Okay. I will show now the scales on the machine.
Yeah.
So that is that was the X scale. So
yes.
something like 61, if I'm something like this. Yes, 62.
Yeah.
So should we now insert this?
So yes, you have two possibilities. Either you move the machine to the position given there, or other way around, you enter the current position.
There is no difference which one to use. So I will enter there the 62.
Okay. So, and the height is usually above the table.
Let me also show everybody the height. It is like it is something like 217, something like this.
Yeah.
So let's put it on. So don't mind us when I shift the camera, it takes some time to refocus. So
yeah, no problem.
It is what it is. Yes.
So, and the probe angle is 7 degrees. 7 degrees is used because at 7 degrees the probe. If you show the probe.
Yes, there is the probe.
So this is approximately 7 degrees, and at 7 degrees the probe ball can touch a flat cylinder without the cylinder scratching the probe system.
Okay, so let me ask you, the 7 degrees, how is it measured now?
This is not measured. This is just an approximate value.
Okay, so okay. So does it makes any? I mean, is it important right now or not? Because I don't understand where this 7 is coming right now. Is it from the vertical? 7 degrees from the vertical?
Yes, from the vertical. Yeah.
Okay, like in this direction. Yes.
Yeah. Yes.
Okay, makes sense.
So.
Yeah,
that's now it's okay.
Now we okay the machine. A reference point run will be carried out. Yes, okay.
Yes, that means the Z-axis will turn.
Yes, it is turning. Actually, it is turning.
So all other axes are just manual axis, means that they don't have a scale or something like this. They have some of them have a scale, but yeah, it's not really you just entered the position. Yeah.
Okay.
So, good. And then we have different tasks for our software. What we want to measure. So first thing is what we usually do at first is aligning the workpiece to the z-axis of the machine, which is center and tilt on the right side.
Yes. Okay. Let me show you to everybody. This is center and tilt.
Yeah.
Okay. This should be our first task. Yes.
This is the first task.
So
Almost always, yes.
I should click it. Yes.
Yes, click.
Yes.
So centering tilt. Now we have to set all these values for aligning the workpiece. Usually you measure the workpiece at 2 circles and 2 different heights. So, and that's why it's just called here given measuring height, and last height is the second circle.
Okay, there is your measuring height and
yes,
your last height.
Yes. So now we decide where we want to make the centering and tilt. If you have a drawing of the workpiece, usually you will find something like notes for references for your runouts or something like this. Mostly they are marked A and B.
You mean like the datums, yes?
The datums, yes.
Okay, so actually we have a drawing. So everybody can see the drawing, yes?
Yeah. So in this case, we have only one reference, it's A.
Yes.
But the reference is relatively large, means that we will do one circle close to the bottom and one circle close to the upper edge.
Okay, can you also help us in defining now the datum is referring to the central axis, or is it axis, or is the surface of the cylinder now?
No, that's the axis.
This is the axis of the cylinder.
Yeah.
Yes. Okay. So I will close this share, get back to video, and I will show everybody that now the datum A is referring to the axis of this of the cylinder of this part.
Yeah.
And now we should set the datum, yes?
Yes, we will not really set the datum. We will align the cylinder to our machine.
Okay.
So, and this is usually done at the datum axis or datum elements or geometric elements.
Okay. So okay, that's good. Can everybody now sees the machine and also the screen? Yes.
So we will go for the measuring height.
Okay, measuring height.
Yes.
Should I now actually move the machine downward?
Yeah.
Because our goal is to have one circle below,
Yes. Yeah.
Another one from the up, yes?
Yes, that's right.
Okay. So that should be, do you see it?
Yes, that's fine.
I mean, the probe angle is quite, how to say, it's very close to, let me show you.
Yes.
Is it okay to proceed like this? Can you see it from the video?
Yeah, I would probably make the probe angle a little bit bigger.
Yes. Okay. So this I can do just by moving the probe with the hand, yes?
Yes, that's a friction coupling inside. So if you just push the probe larger, more than, yes. So, and then you just
like this, I just push it, yes.
Yes, and then it's just coming a little bit back. So what the range, what is coming back is the measuring range. If you're just exceeding this measuring range, you will just, you see the.
And it is only in one way. I can only
one direction, yes.
Yes, only one direction, yes.
So And now I can see already that the direction is wrong. We have to change the touch direction at the probe.
Yes.
This is the black.
Okay, let the black what?
The black knob at the T2V. The probe unit is called T2V.
Okay. You mean the physical one, this one?
Yes, this one.
Okay. And we need to turn it right now. I think it is. Okay.
Yes. Now you can see that the probe is, yeah.
Yes, it's hard.
Okay. Good.
Yes.
Yes. So. Okay.
The measuring height. Let's set it.
Yeah. Yeah.
Okay. Well, here. This one. Yes.
Yes.
And just click OK. Was it so?
No, because the machine is not reading the values from the scale. So you don't really need to. The machine needs to have the height or the position of the z-axis and to calculate the angle of the axis. Yeah, that's why the machine needs to know the two positions.
So if what I did now, I just clicked the field.
Yeah.
And it gave us some value. It is like minus value. This doesn't make sense, or?
No, this doesn't really make sense.
Okay, so I would need to click this keyboard and just enter the value we are reading. Yes?
Yes. Yeah, that's okay.
It's 1, 5, like this.
Yes, okay.
And click OK. And now we will go up with the probe.
Yes, we will go up with the probe.
Let's say somewhere around here.
That's right.
Let's say, and then we will put last height over there. Yes.
Yep.
And the value over there would be something like 264.
Yes, fine.
Okay, fine.
Okay, now we can press start and the machine will guide us through the process.
Okay, but I don't need to go and touch the part, no?
Not yet. The system will just tell you what to do, because the machine is moved manually and the machine and now you are asked to move the z-axis manually to 153.
Okay, we just took a little bit too big part, too much moving here.
Yeah.
Yes. So it is 169. Sorry, it is 153 as said.
Yeah, whatever, yeah.
Just click OK.
Yeah.
And then we would need to go and
the problem is that the machine doesn't really accept this. We have to go with the values that are coming from the scale. We entered the scale values.
Yes.
Yeah.
We entered, you see,
yeah, this. Yes.
3. So
and the machine is just comparing this to the scale that is attached to it. So we have to enter the values from, just take the values over. So
okay, so
retry.
Abort, yes.
No, yeah, we can also abort, yes. Okay, we will do it everything again. So and we will just enter the values, measuring height.
Like,
yeah, with the keyboard, and then take the value that is entered. Just okay. Yeah.
Like this.
This, yes.
Okay. And the same with the upper one, yes.
Same with the upper one, yes.
Okay. Is there a short explanation to what is going on right now? Why do you have something on the scales, something totally different, and something else on the screen?
The scale position is always something that the machine can really read from the electronical scales, and the electronical scales are not exactly giving us the correct height of the probe ball above the table, because we don't really know the length of the probe and many other things. For this reason, we always have a difference between these two.
Okay, so now we've done it, and we will try to start one more time.
Yes.
Okay. So need to go down to this -35, roughly -36.
Yeah.
30.
Some
like this.
Yeah.
And then click OK.
And click OK.
And now we will go to the contact with
yes.
With the probe until it is in the center, I presume. And click OK or what?
Okay, yes. And then the machine will just move the table.
The table is rotating.
I can see the part is a very good aligned already. So, and now we go for the second position.
Second position was up.
So if you would like to protect the probe a little bit, you just remove it from the workpiece. This will just reduce the wear of the probe ball against the part.
Understood. Yes, and click OK.
Okay. So, and then move to 0, contact again. That's okay.
Ma muidugi kardan, et see oli meil aastaid tagasi kuulutasin peale.
So, and now the machine is calculating what is the, and now you are asked from the machine to turn the red knob with the x-axis until you reach the scale position showing there. So just try and so okay, and if it's green you can stop, but you can also continue and just yeah.
Let's make it as small as possible.
Yeah. Okay. Yes. So the same now with the green one. That's now Y direction.
Exactly.
Okay.
Let's say okay.
So the machine should now.
Now it wants to measure again. Yes.
Wants to measure again. Yes, that's fine.
Let's measure again. Too much. Like this.
Okay.
And okay.
So you already position to 0 the machine or within measuring range. That's the machine, the software recognized this and started the process of measuring immediately.
Yes.
If the probe would have been not in contact, the machine would have asked you to contact.
Okay, okay. So now we go up.
Yes, to the second position.
Yes.
We now move the part, so that's the machine needs to verify that the movement was correct. That's why we have some like check measurements.
So we go in contact.
Yeah.
And initiate.
So, and now we got already the results, means that we have the current eccentricities of these two circles. And these are 9.4 and close to 4 micrometers.
Yes.
Yeah. So I'm not sure why this is not asking us to repeat this. Okay, we will look at it later. So this is usually it should now be repeated.
Okay, it should be repeated because the number one eccentricity is too high.
It is too high, yes.
Okay.
Yeah.
And number one is now referring to the first measurement. Is it so, or is it the what does it?
Number one is the first measurement. No, that's the cycle. That's both measurements. Sorry.
Okay.
First we had 9.4 for the first was the worst eccentricity of one of the circles was 9.4 micrometer, and then after the second cycle we have the worst of both cycles was so that the result is okay. So result is okay. I was also looking for the I thought this was circle 1 and circle 2. No, it's cycle. Cycle, that's the first measurement step and the second measurement, control measurement. So we are just in range. Wonderful.
Excellent. So can you please comment a little bit on the meaning of the eccentricity? Is it now the similar as it would be the roundness? I mean,
no. Eccentricity is the distance of the circle of the measured profile to the z-axis.
Okay.
Yes. No. So if you just have a look on the screen, so you can see the scale.
Measure difference.
Yeah. So this circle, yes, the measured profile. The profile will just be evaluated. So you will just calculate a Gauss circle. Means that the mean distance of the circle, the profile points to the circle is the minimum. And this will give us a center point of this circle, and the distance of this center point to the z-axis. This is our eccentricity.
Okay, just to be clear, I will try to draw a sketch.
Yeah.
So let's see if this would be our C center line.
Yes.
That would be our C. So eccentricity is somehow giving us a distance from this axis, or?
Yes. The distance of the center point of the profile for the measurement. So if you make a circle around, which is a highly so
yes.
So, and now this circle has a center point.
Yes, like let's say
Here, yeah.
exaggerated over there. No,
So,
it is not correct, but anyway.
yeah. Okay.
Do it again. So there is C.
Yes, and then you have a circle. Yeah.
Let's call it C prime.
Yeah. And then this is the eccentricity, is the distance between these two.
Like this.
Yeah.
But this distance, okay, it is like the straight distance, okay.
That's the straight distance.
Okay. Let's leave it here. Yes.
Yeah, and if you have a scale, in this case, we can just see, if you just go a little bit closer with the camera, you can see that, in the bottom left corner of the this graphical area, you find the scale for the,
Yes.
so it's 5 micrometer. So, and now you see these two small X marks. And these are the eccentricities of these two circles. Yes. So, and then you see that the one blue one is very close to the 5 micrometer mark. Yes.
One.
And that's the other one. No, this one. Yes, and this one.
Yes.
And this one, this is
one. Yes.
this is, it has the bigger distance to the real center.
Okay. The
Real center
is
is,
over there.
yes. Yeah, that's right. That's the z-axis.
Okay. Let's say we have successfully centered this particular part. Yes.
Yes.
So in principle, we could start the measurements.
Yes. So why we are doing this? This is very important. Usually you could measure right away something like say eccentricity or something like this. But the problem is always that we have a probe, and the probe has a measuring range. And this measuring range is somehow divided into several thousands digital steps. Means we have for the complete measuring range about, let's say, 1 millimeter measuring range, and we have 1000 steps, then each step is just 1 micrometer. So, and if we move the probe a smaller range, we still have these 1000 steps. So we can just reduce the error, because the measurement always has an error. And this is always the half of the step size of the resolution. And we don't know exactly where we are inside this step. So that's why we try to make the measuring range as small as possible. And then make the analog digital converting. And so we have very, very small digital steps, and we don't know with the small error inside. The second reason is if we have an eccentric part, we will not measure at the zenith point. Workpiece. So here we have the workpiece, and then we have our probe. Small ball is the probe.
Yes.
And if the probe is not touching at exactly at the zenith point, then we get a measuring error.
Okay, so
Yeah.
right now you were saying that the probe should touch at the 9 o'clock position. That was,
yes.
and
Yes.
when it is not, then we get an error. Yes.
Yes, and this if the probe the part is highly eccentric, then this position will vary over the measurement. So 1 second, next. So this is the workpiece. So, and so now we have the probe is touching the part. So the part center is here. Yeah, this is the part center, and this is the probe, and the probe is touching. So now the workpiece is turning. So, and now it's just above rightly. So, and then it's turning around, and then the probe is touching here. Means that the position of the probe is just wandering just somewhere around here, sometimes there, depending on the part position. And it's just turning around. And to minimize this, you just align the workpiece to the machine axis.
Okay, excellent.
Yeah. Good. That's why we make centering and tilting. So we have finished now the centering and tilting. So we add this to our multi-feature. Multi-feature I will explain later.
Okay, so sorry, I will close your video. Is it okay? And
yeah, that's okay.
Then ours will be bigger on the screen.
Yes, of course.
Yes. So or stop video. Yes. Okay.
Yeah, I'm not really.
Oh, anyway, ours is still the same. So okay, let it. So
Good.
add to the multi-feature.
Yes.
Yes, done.
So then we can go to selection again.
Do selection.
So now we can build an axis, because on our drawing there was given this runouts or was given to axis A, datum axis.
Yes, so we go datum axis.
Yes.
Let's see, we are trying to solve. Wow. Datum axis, yes.
Datum axis, yes. Again, we have to give, so we can give the axis a name. In this case, axis. I would say axis underline A or something like this.
You mean like A, like this? Yes.
Yeah, or axis A, whatever. So that's okay. That's okay.
Let's do it axis A then. Or
so,
as you said, underline A.
Yeah.
Okay. Yes.
So, and then we just enter the measuring height position again.
Like this.
Yeah, and the second one last is the where we are at the upper position, so we go for the lower position.
And then I need to manually again move the,
or you know the position.
Yes, it was minus 36.
36, yes, then it's okay, also fine. Yeah.
Should I? Okay, it's okay.
Yeah, that's okay. Good.
And
so
then start.
Start, yes.
First I go to the upper position, or no, we start. Okay.
We start and the machine will tell you what to do.
Yes, so we go to 72 like this.
Yeah.
Click OK. Click OK.
Yeah.
So now we are establishing the datum. The datum is A axis. Okay. Yeah. We go below.
Yeah.
Click oh yes, also this one. And okay.
Good. Okay, axis A created. Yeah.
Yes.
Mm. Also add to multi-feature. Good. We go for our selection again. And then we have a look on our drawing. I don't have the drawing in my mind, so please, can you show it again?
Share screen.
Yeah, would be good.
Share. And we have these runouts over here.
Yeah, so we have to run out.
It's I think we have to look on this part. I'm not sure why do they have two runouts here. It seems that there should be some difference in diameters.
Yes, there is a different in diameter. So you have diameter 12.5, but this is internally.
Yes, it's internally, yes.
Yeah, so in this case, we will just have to go internal.
Okay.
No problem, we will just do this.
No, let me first, okay.
Yeah, let's start outside. We will make a run out anywhere outside just for testing, to demonstrate. Yeah.
But still, I don't understand. Where do you see two diameters? There is the same value, diameter 12.
No, this is the on the left side you have diameter 12.26, and then you have 12.26 on the right side, and in the middle, in the center, you have 12.5.
Okay, yes, correct.
Yeah.
So, but as you said, yes, let's first measure some runout outside. Okay.
So I would say now we have we did alignment and the axis on the upper two and a lower position. So we make a run out close to the center of the part. So and we have a radial run out.
Exactly. We check radial run out.
So. Okay, so first we have to use the datum. So datum, we named it axis A. So you clicked axis A, just edit.
And so let me ask, these old ones, they are in the memories or what is something? Yes.
Yes.
But okay.
So, and now we go for the measurement. We click on measure.
Measurement.
Yeah. So
but the tolerance is 0. Should we put?
Yeah, if we don't give a tolerance, the result is always green. So we don't really have a tolerance for outside, but you could also give 10 micrometers there.
10 micrometers. It's 100th. Yes.
So, and now measurement. So, and then we will just measure at the center position of the part somewhere.
Okay, I will position the probe in the middle, roughly. Yeah. Fix that position.
Yeah, okay, good.
Also contact the surface, yes.
Yes. So, and then you can go for the measuring range.
Measuring range, yes.
Yeah, so we can select the measuring range 2. This is the smaller measuring range because we have the part aligned. We don't need to use the measuring range 1.
Yes.
Yeah, and then start. Yeah. So you can see now the scale in the bottom was just changing from ±1 millimeter to ±0.1 millimeter.
Yes, exactly.
So, and then this machine is asking us to make the zeroing. Yeah.
Okay, well, but now it is already difficult to do it with this peak button. If
Yes.
I remember correctly, that was a fine adjustment somewhere. Was it this
Yeah, this one. Yes, I guess. I don't have this MMQ100 here in MAR. We will only sell them.
Okay.
It's very rare that I'm using this device.
Why?
Because usually the industrial processes are fully automatic and no one has the time to make this manual.
Okay. So now it's measuring.
Yes, and this is the main reason why almost no one has this MMQ100. And if they have something like this, then they will just make only rarely measurements on this
Okay.
for
So
prototyping or something like this. So run out. So value. Oh, we have a value of 35.6. Wow. Okay, you just have a banana there.
Okay, let's try to let's interpret this result a little bit now.
Yeah.
The value of the run out now, it is giving us, I mean, theoretically run out is a measure between two circles. Was it so?
This is exactly, run out is the radius distance of two circles around the given datum axis.
Okay.
And all profile points must be in between these two circles, like we see on the right side. So that we have an inner circle touching the profile probably at one point. Yeah.
This is the one. Yes.
Yeah. Yeah. And they both have the common center.
Yes, and that is the C, the let's say the nominal center of the machine.
Yes.
Yes.
So
and then we have the other one.
Yeah, and then we have the other one, and the distance between these two, when you just count, you have the scale on the bottom left corner, you can just count it. So it's microns. 10 micrometer, 1, 2, 3, and a little bit on one and the other side. So it's approximately 35.6.
So okay, I mean 36, it's microns. So it stands for how much? It is 0.04 roughly.
Yeah.
No.
So.
But okay, it is 400. It's not that bad, or
no, that's 35 micrometers.
Yes. Okay. Let's do this calculation also together. If I just try to put it to millimeters, it means it is roughly 0.04 millimeters.
Yes, that's right. Yes.
And I mean that is okay, or is it not?
Depending on what you want to do with the workpiece.
Okay.
So if this is an injection part, this is a crap. If it's something for a shaft for agriculture, it's probably very good.
Yes.
So
okay.
Yeah. No one really knows. So this is what I usually tell the customer is that we measure giving you only the tools. You have to become the master of the tools yourself, and especially of the workpieces you want to measure with them. Yeah. So it's like making some crafts or art. So I can give you a hammer and the other tools and explain how to use them, but you have to create the art yourself.
Okay.
So, okay, add to multi-feature.
Add to multi-feature.
Yes, and now we go for the selection again.
And let's see what else we can measure.
So now I would like to do a roundness.
Roundness measurement.
Roundness,
Yeah,
yes.
yes.
So, and in this case, we don't want to measure again because we have this this circle already measured. So we go for reuse.
Reuse.
So, and the circle we have here is radial run out 1. Should be radial run out 1.
Okay, we should have radial run out.
Run out 1, yes. So
Okay.
we were.
But let me ask you, why is it memorizing all these previous measurements? Because it is kind of confusing right now, in my opinion.
Yeah, that's what we can also delete them later. So this we will make when we just finish this program.
Because I mean, obviously these older measurements, they belong to some who knows what parts right now.
I know.
Yes. Okay. So let me add this one to there. Okay.
Yes. So and then we can go for the task for the settings.
We go
settings. Evaluation. So we have now here different evaluation methods. So these different evaluation methods you will just get from the standard. Usually it's something like the Gauss circle, that's very common. And then we have the minimum zone circle. This will always give you the best result. And then we have the minimum containing circle and the maximum inner circle. So we will try just change to minimum zone circle. MZC, yes. Okay, and we just say start.
Okay.
So now we can see directly that our circle is there. We have a value for the roundness of 2.28. So if you remember the run out of their circles, they were exactly the same circle, but with two circles around the axis of the workpiece. And now we have the two new circles with a common center, but with minimum distance to each other that are containing all the profile points.
Yes.
So this is minimum zone.
Okay.
So we add it to the multi-feature. So we do exactly the same again. We go for the roundness.
One more time, selection.
Yes, yeah, selection, roundness.
And we change the position.
No, we don't change the position. We make a reuse again. We use the same circle.
Reuse, try to find the
same circle, run out 1. Yeah.
Run out 1.
Yes, and then we go for the settings. And now we use a different evaluation method. LSC is the next most common.
That is the least square circle. Is it so? Yes.
Yeah, least square circle.
Okay, start.
Yeah. So now you can see that the value slightly changed. It's getting a little bit bigger.
Yes, yes.
So add to the multi-feature. So what happened now? The center of the circle was before we had two circles with the common center with minimum distance to each other, containing all the values. In the second evaluation of the roundness, we have calculated a least square circle. This is giving us a center. And then we have again two circles that are containing all the profile points. And the radius difference between each other is 2.55 micron.
1 minute. Somehow we were able to kind of magnify, to change the scale of this drawing Right now,
Yes.
scale unit is 10. How do I change it?
If
Easy
we
or not?
just go for edit, yeah, edit. Yes, we want to edit it, and then we go for the result. I think the result, yes, and we have changed to centered.
Polar center.
Polar centered, yes. Okay, apply. So.
Oh yes, now it's
yeah.
really magnified.
So, and then we'll do the same because now you don't see the eccentricity. Yeah. So, and that's why we don't need the big scale. So, and for the, we can go, do the same for the other roundness to just see the difference.
Roundness, edit.
Edit, yes.
Okay.
So, result, also polar centered, apply. So, and now you see the two circles where they are touching.
Yes, this clearly. But
yeah,
if we now go to this least square, how can we just have one circle here?
The circle, this is the reference circle for these two circles that are not shown for the that are touching the profile at the inner and the outer position. So in this case, we have, for example, the inner circle would approximately touch the profile at the 9 position at 180 degrees.
Okay.
Yeah, you see that.
Like over there?
Yes, like
okay,
over there. And now we search for, now we search for the maximum profile point outside. This is probably close to 90 degrees or 100 degrees or maybe here close to 70. I don't know which one is the maximum. Yeah.
Okay, I think we get the point.
Yes. So, and then you can just count again. So that we have 1, 2, 3, 4, 5 scale
units, yes,
units, and 5 multiplied 0.5, it's 2.5. So that's close to the. So, and if you just have a look for the other one, for the other roundness,
yes,
you can see the same.
But here we have two circles.
Yes, we have two circles, and these two circles are just calculated that way, that these two circles have a common center, and each circle is touching the profile at 1 or 2 points.
Yes.
So if you, especially for the inner circle, you can see here now that the inner circle is touching at approximately 1 degree, 0 degree, and 180 degree.
Yes.
And if you just go for the other roundness, then you see that the profile points of at 0 degrees are far more outside, means that the center point is at a distant position.
Okay.
It's the same profile, but the center point is different.
Okay.
So, and this we can do once again. We can just go for selection. We go for roundness again. We reuse the same circle. Yeah, we go for the settings, and now we for variation, and now we have the MCC.
That is the maximum. What is it? Maximum.
Minimum containing circle.
Minimum containing. Okay, and the last one is maximum or something. Yes.
Maximum inner.
Yes. Minimum containing circle. Let's see.
Yeah.
I started. Okay.
The smallest circle that will contain polar, change to polar centered. So that's the smallest circle that will contain all profile points.
Okay.
This circle is touching the profile exactly at 3 points from outside.
Okay, but now the question is, what is this value showing? Or
This is again the value of the two circles with the same center point, where the outer circle is now touching the profile at 3 points, and the inner circle is just having the same center point like the outer circle, and touching the profile at 1 point from inside.
Okay, and sorry, the inner one is not shown. Am I correct?
Yes.
Not shown here.
Yeah. We only show the reference circles, and the reference is in this time this case the outer circle. So add to multi-feature, and now we may do the same with the inner.
So selection
roundness we use
check for this one.
So settings, evaluation,
and this one.
Yes.
And
okay.
Start.
Yeah. Polar centered.
Polar centered. Yes. Okay.
So, and now you see that the circle, the profile already looks completely different.
Yes.
Yeah, because the minimum inner point, maximum inner circle is has a completely different center point than all the other circles. And also here again we have an outer circle that is not shown with the same center point, which is touching the profile at exactly one position.
Okay.
Yeah. So
yes,
now we can
methods. Yes. Okay.
Yeah.
So we add the multi-feature, I presume.
Yes.
And let's see what else we can measure from outside. Roundness we did.
Yeah.
Can we have the straightness of this cylinder?
Yes, we could also have the straightness of the cylinder. Yeah.
Let's do it.
Yeah, we can do.
We can do straightness. I will give it the name so we will recognize it. Okay.
Mm-hmm.
And so
we want to measure that's okay, and we give a starting position. I'm not sure where we are.
We are roughly in the middle right now.
So okay, then that's fine. That's good. That's good. And we just set start position, and let's say we go up how much? 20-30 millimeter. Let's say 30 millimeter. Just click on the measuring height. Yeah, and then we just go from, let's say, 10 millimeter, that's 1 millimeter down, to
upper. You mean we go?
No, we will just go down. I just want to go. No, that's okay. Fine, not so much. So, and now get the position.
This one?
No, I want to go up. We can change this from start to from 0. Make the measuring height Z, the first one, set it to 0. Enter manually. 0, yes. And the last one, we would just enter, let's say, I think 50. Okay, let's see what happens.
And just click start.
Yes.
Need to go to contact.
Yeah.
Okay.
Okay.
So to evaluate straightness, now it's doing what? It's measuring 2 circles, taking the center points of the circles. Or...
Yeah, that's what I think. What the machine is doing.
Position manually to 25. This equals scale value 109. Let's see.
Yeah, no, it
Oh,
must be up.
it must be up, yes.
Yeah.
So we are at 25.
Yeah, you can see it in the bottom left corner of the air.
Exactly, this is what we are. And then we will approach the part.
Mhm.
Like so.
Yeah.
And one more time.
One more time, yeah.
50. Like this. Okay. Okay.
So now we have a line. Yeah, you can see that what is shown here is the points of these center points of the circles according to the z-axis and the position, and then you can see already this is a kind of banana. Yeah. So the both upper and lower point are just in let's say about 300 degree direction, and the other one is at about 120 degree direction.
Can we please go through this one more time, because I'm not sure if I quite get it, this explanation now.
We have now the system built a line out of the center points of these three circles.
Measured circles, yes.
Yes.
1, 2,
2, and 3. So we don't really see here the circles.
No, only
No.
partial circles.
No, it's only partial circles, and that's only the arrow is pointing in the direction where the center point of the circle is according to the z-axis of the machine, or the z-axis. Yeah.
These arrows.
Yeah.
This one, and this one.
This
yes.
one.
Okay.
So and now you can imagine that these circles are just in one, let's say one plane, but just like a bow or something like this. I think this the part is not really straight. So if I just I need some paper. 1 second. I will just show you on the camera. I try to draw this.
No, 400 kuradi tuhandikku, see on minu arust päris sirge.
My camera.
Yes. But I mean, we are still wondering. It is only 4 thousandths, 4 micrometers.
Yes.
Of an error. It is.
Yeah.
It sounds really straight to me.
Yeah, this is always depending on the task what the workpiece should fulfill.
Okay.
So for an injection part of your diesel, it's way too much. For a bolt of agriculture coupling,
It's okay. Yes.
this is nothing. Yeah.
Yes. Yes.
So I cannot switch on my camera. So
Oh, let me see. Perhaps I did something. I will
yeah,
try to
I guess.
whoa. Ask to start video. Let's see what we have.
Yeah. Okay. So here we are. So my video. So you can see that the straight line is here the center axis,
Yes.
and here we have our circles with the center points, and this is the axis that is given from our center points. Probably the part is bended like this.
Okay, now we see. Yes. Yes.
Yeah, and that's what we can also see on our graph.
Okay, this is clear.
So, and the straightness is now the diameter of the cylinder that is just containing all of these center points.
Exactly. Yes. Okay.
Yeah.
One more question. And why do we have these partial circles? You gave an explanation, but what was the meaning there?
This is just a way to visualize the position of the center points according to the axis, and this is not really something that is really. I think the circle sections are not really necessary.
Okay. So let's leave it here.
The main important things are the arrows.
Okay.
This is design. So we can add this to the multi-feature if you want. Yeah. Okay. Good.
Yes, sorry, let's proceed.
Okay, now we can do the measurement inside the bore.
Okay, sorry, one thing which we were just discussing between ourselves. So let me show you.
Yeah.
Let me show you one tolerance. Share screen. Take the drawing, and there was this perpendicularity.
Yes.
Tolerance.
We could measure it, but in this case, our workpiece is clamped like this that we cannot reach it.
Okay. So perhaps later on we can actually turn it and try to evaluate this tolerance.
That's what we will do in the next step. Yes.
Okay,
definitely.
Excellent. So stop share, and now, okay, sorry, I will take it back to show everybody what we are going to do. Now we are trying to evaluate, let's say, this tolerance, this runout value here.
Yes. So, and that's where we have to measure is, let's say, about 5 millimeter inside the part, and more than 20 millimeters inside the part.
Yes, for the second one, for this one.
Yes.
Okay. Yes, correct.
So and then we name it inside up and inside down, or something like this.
Yes. So I will stop this share.
Mm-hmm.
And we are ready to proceed.
Yes, we go for the run out again.
We go for the radial run out. We can use our axis. What was it?
Axis A.
It was A, yes. Add
yes.
This. And we need to run out. The name is run out. I will frame it run out 21.
No, I would go inside up or something like that.
So let's do run out
in up or in down. Yeah.
In up, then
up,
let's start.
yeah.
Okay.
This is always naming the measuring positions is always a tricky thing, because you need to find them on the report and know what to where it was measured.
Absolutely, yes.
And either that's why often they have a kind of quality plan, and then all the measuring positions are named with numbers. And then you have a measuring task number, and you just enter the number and name something like this here.
Okay, and we can also now add the tolerance here, but because
Yes,
we had it on the
drawing. Yes,
it was 0.1.
0.1. Yes.
Is it okay?
That's okay. The
That's
machine
okay?
should add the 0. Yeah.
Yes.
No. It's 10 millimeter. 10 millimeter is a little bit too much.
Okay, it was my bad.
No, why? This is.
Let me check the drawing.
Yeah.
Yes, it is 100th.
Yeah, 0.01.
Yes.
10 micrometers. Yes.
And
Measurement.
Okay, now we need to go somehow inside.
Yes.
And the direction is still good.
The direction is still good. Yes.
Direction is still good. The angle is also, I think, sufficient.
Yes, that's fine. Maybe we have trouble with the angle if we are in the lower position.
Absolutely, yes. Then we
could be that we have trouble there.
But right now we can just eyeball it.
Yeah.
I mean, eyeballing also the height.
Yes. So I would use the center of the ball.
Okay.
To see that where's the edge, and then remember the value from the scale. So yeah, a little bit down the camera, that we can just see the half of the ball. Yeah, that's tricky. Yeah, a little bit more up. Yeah, so now it's half of the ball. Yeah, okay, so now we have found the upper edge position. I get.
Yes,
I would guess approximately. So this is not very accurate, but this is accurate enough for form measurement.
Okay.
So I will explain you later why this is the case. So we just remember the position. If you show the screen, so that's
89.
89. So and now we want to go 5 millimeter in, so we go for 84.
We go to 84.
Yeah. Yeah.
Should be okay.
Should be okay. Fine. Okay. And then we just take this position also in our
to measuring Z.
Yep.
Like
okay.
Yes.
Yep.
And measuring range 2, I think.
Measuring range 2, yeah, should work.
The let's say the more accurate or more sensitive one.
Yeah, that's fine.
Okay.
Okay, and press start.
But the datum?
Datum is already selected. We don't need
yes,
to.
Yes. Yeah. Okay. And we start.
Yeah.
Go in contact. Yes, okay.
Okay.
Okay. It is out of tolerance for sure,
Yes.
at least right now.
Yeah.
Okay.
And now we will go for try to reach the second one. So add it to the multi-feature.
Add this to multi-feature.
And then see if we can reach the other position. If not, okay, we will skip it. So it's a training, so it's not important.
Actually, I mean, this is a part we would like to measure, to evaluate, because
Okay.
we have people interested in the results.
Okay, then.
But anyway, this is a real life scenario, because now we would actually need to change the angle of the probe during the measurement.
Yeah.
So how should we approach it now?
So we will just go a little bit up.
Come out with the probe.
Yeah, come out with the probe. Yeah. Then make it almost vertically. Yeah.
Something like this.
Yeah. So
I mean, it's hard to see from the angle of the camera, but I can.
Yeah. Okay. Yeah.
More vertical.
Yeah.
Oh, the same scenario.
Yes.
Go and eyeball the center.
Yes.
Consider it to be 90 roughly.
Yeah, so 19. Probably I would go for the same value.
You mean same value?
It means 80, 89, but this is not so important. Just we'll go in and then see if we can get 25 down or 22 at least.
So we go to 68.
68, yeah. Just have a look on your probe if it's touching the workpiece somewhere.
No, the stem there is still clearance.
Yeah, okay, then it's good.
Not much, but something.
Yeah, but we are still not deep enough in.
Okay, I'm afraid this is the deepest
We can move a little bit the x-axis, so just don't be afraid. So as long as the part is not touched, so no problem with that.
Okay, my bad. I was not considering this.
No problem.
That was easy.
Yeah.
Okay. Like this.
Yes.
And same thing.
Yes, we will just go for the measurement. Yeah, select
Radial runout.
Runout, yes.
The tolerance value 10.
Micrometer. Don't forget
and
the micro.
Was, sorry. It was in down.
The in down, yeah, something like this.
In down, we would need to use the axis A.
Yes. And measure.
Measurement. Measuring height from here.
Yes.
Yes. And actually measuring range 2.
Yes.
And actually start.
Yeah.
And click OK. Wow. That is even stranger. Yes, there is.
Yeah.
Not sure if we are. Might be the.
No, I think that's fine. Probably the alignment of the bow is not correct.
Okay.
As long as you have not seen the shaft of the probe touching somewhere, I have no doubt that this is possible.
Okay. Yes, that should be okay. Yes. Okay. Okay. So yes, that's that then.
Yeah. Add to multi-feature and then
The well, okay, there is this strange phenomena here. I would perhaps like to ask. I don't know how well you can see it, but there is kind of it's not even a circle anymore.
yeah, because we probably we are leaving the evaluation range of the probe. So if you go back and switch to measurement range 1, you will have a full measurement.
Go back, you mean?
To the measurement, yes.
Okay.
So, and measuring range 1.
Okay.
And start. The problem was that the workpiece was
okay, it's better.
leaving the measuring range, so that the points, the recorded points, were invalid, and
okay.
For this reason, the machine were able to yeah, make this strange profile, because the last valid points are, yeah, the typical points for the run out that are taken into the calculation. So, and now you see that your value was getting even worse.
Mm-hmm. Yes. Okay. But then anyway, now it looks all is black. There is no this red section. I think this red meant out of range.
That's right.
Okay. So add multi-feature or no?
Yes.
Does it mean, okay, now it just added one multi-feature, yes.
Yeah.
Okay. So from this position, what else could we evaluate?
I think that's almost all we could really evaluate there. Let me see the drawing once again, please.
Let's open the drawing. Share the drawing. Share.
Yeah, there's not really much more for the machine to measure here.
Okay. So anyway, perhaps now we have worked for 1.5 hours. Let's have a 5-minute break.
Yeah.
And then after the break, let's try to evaluate the perpendicularity.
Yeah. So we have our multi-feature. If you click on the multi-feature.
So let me find the multi-feature.
Yes, and then we can just, of course, click on save.
Save. Now we save it. Save is up there. Yes.
Yeah. So and then we will just name this file like I don't know the workpiece name, maybe
training. Okay, already.
Yeah. Okay. Okay.
13. Oh no, today is 14th October. October 22.
Yeah, so I usually use the numeric format with the year, month, and day.
Okay.
This is because it's easier to sort then.
Okay. We just need to practice this. Yes. Okay. So I save it.
Save it. Yep. Okay, so, and before we do something else, now we can just press start.
Start.
So yeah, if you start in the upper left corner,
This one, okay.
yes, and then so the complete program will now start again. So we will just go there and follow the instructions, and you will get the same result again.
And this would be now, for instance, if we put in another part, or
Yes, would be for the same type for a different part.
okay, which we don't have. But when we put in a different part, should we then do first tilt, center and tilt?
Of course, yeah. Center and tilting is now included. So
Okay.
yeah.
Okay, it's now included. Yes, yes.
It's all included in the program, so
okay, I see,
you
yes.
don't really need to think about this anymore.
Just clamp the other piece and run it. Yes.
Yes.
So I will give it over to one of the students. Okay.
Yes, that's good.
Okay.
Could you do me a favor before you would just start play around with the X, Y, A, and B axis a little bit, that we have some misadjustment to see the alignment procedure again.
X, Y, yes. No.
Yeah.
Okay.
Yeah. Everything just a bit. Yeah.
Yeah. Perfect. Thanks.
So now we misaligned it purposely, yes?
Exactly.
while we are doing this, I would like to ask, is there a way we can kind of check the machine? Let's say if, for instance, we take for instance, if we take one of like these calibration rings,
Yeah.
we measure it inside.
Yeah.
This should be quite round. I mean, it should be close to perfect. Yes.
That's right. Yes.
Yes. This with this one we could in principle check the machine itself in a way. Yes.
If you just want to check the machine roundness or the axis, if the guide of the axis is still fine, then there are special roundness masters available.
Okay.
These roundness masters, they are perfectly round and they don't really have a diameter.
Okay.
But in this case, they are perfectly round, and you can get them with a deviation from roundness from below 30 nanometers.
Okay. And
So,
do you provide those, Mar? Do you
yes,
sell them?
yes. If you
Are
want,
they-
you can buy something like this, but it's probably more expensive than the complete MMQ100.
Oh, okay. 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 I think the program now crashed
That's not good.
in front of our eyes.
Yeah,
Yes. Don't send error.
don't say it. Yes.
But anyway, we got an idea. So
Yeah. So before you start the program, please open the Explorer, the Windows Explorer,
okay, we already opened it again.
or whatever. So you can use the Windows E. So, and then we go for C, MAR, and then users. So, and then we have the user we want to work with. So I think we log in as with your user, and then you have the temp folder. And the temp folder you can see if you have a look for the details. Just not the icon view, just the detail view. No, upper right. Yeah, okay. Yes. So, and then you can see that we have different files, and we have these PRF files. Maybe you have to show the extension of known files to see them. So this is with the folder options. I think this is options. No. Must be in the menu of the Explorer somehow, the folder options. Oh, that's XP. Yes, and then view, and then don't skip extension of known files. Must be something like
extension.
yeah. Okay. So, okay, and now you can see all these files, and then you have there things like feature, FEA. This is a kind of result file. or SEL, so that doesn't matter. SEL, this is an element file. So this, if you want, you can also have a look inside the file with the right mouse button and open it with a text editor. So WordPad or whatever, yeah. So and there you can see what type of element it was, where's the coordinate system, and so on. This is just for information. And if you don't want to have these files, especially these things like old access, so if you see there you have this access, so then you can just simply delete them, and then you get rid of them to
Okay.
so
Okay, understood.
yeah.
Mhm.
So the temp folder can always be completely deleted, and then you are all of these old files, old profiles, and so on for reuse. That then they are gone. So I think now we try to make it a little bit better with the probe. And we don't enter the values from the scale. We see we measure really from the position between the probe and the table surface for the Z height.
Okay.
I think this is much better.
So how do we do it?
Just with a ruler.
Ah, okay. Okay, now I see what you mean. So I have a tape measure I could find. And with a tape measure, you mean we roughly estimate the height of the probe set from from this surface?
Yes, from the table surface. Yes.
Okay. I mean, it doesn't need to be very exact, or
no, it's not. Only that we are approximately in the range.
I'd say it's 120.
Yeah.
So in there we put 120.
Yeah.
And it's millimeters.
Yes. Okay. So and for the radius, I would probably contact the probe ball to the workpiece.
And let's see how much it was. I will share the screen. The diameter was 24. Yes.
So then it's 12 plus ball radius. Then it's 12. It's 30, 35. 30, no, 13.5. Sorry.
So I will very gently try to touch it.
Yes.
And over there we had 12, like the radius.
Plus the radius of the ball, because it's always mentioned the center of the ball.
Okay, and this is what is it? 4 millimeters or?
It's usually 3 millimeters.
3 millimeters. So in this case, we should have 15.
No, it's 3 millimeters diameter, so it's plus 1.5.
Okay.
So that's why I said 13.5.
13.5.
Yeah.
Actually, I can. This is backspace. No. 13. Sorry, I'm a little bit like this.
Yes.
Millimeters like this.
Yes. Okay.
And the probe arm angle still not.
Yes, I would leave it at 7 degrees. So
okay.
that's fine.
Okay. I don't know. Should we now try to evaluate the perpendicularity, or I could show you the other part we have under question, because
yeah, okay.
This part was actually, I mean, something that there was a company who wanted to measure it. That's why I brought it up here. This
Yeah.
one.
Okay. Yeah.
And the other type we have also from a company like a measurement task to our measuring lab or
Yeah.
dermatology lab. This is a part like this.
Yeah.
And they have issues with I think it is called the axial runout of this surface.
Yeah.
Because I mean, this is a rotating, they will put it somewhere. It starts to rotate, and occasionally they are not happy with the runout of this surface.
Yeah. Yeah.
So in principle, we can do it.
Yes, we can do this.
Okay, but first we would need to mount it. Yes.
Yes, that's fine. Do you have the drawing too?
Somewhere, yes.
Yeah.
But anyway, let's first measure it without the drawing, because I would need to look for it and it would take time. So
okay.
This table we can turn easily in one direction, was it?
Yeah.
Just to find the location of the mounting.
Yeah.
Which is over there. So let's take this one off. Let's unclamp this one. We have this special chuck.
Yeah.
Kind of special. I mean, this is. Let's see if it opens up enough so that we can actually attach the.
Usually, you don't need to.
Okay, right now it is.
Good.
It's good.
Good.
So I will clamp it.
Yeah. So in this case, we would just make a different way of alignment.
So it's clamped. Okay, and now, as always, we would need to start with alignment.
Yes.
You were saying now.
So usually centering and tilting is yeah, I'm not sure if this is working there, but you could try. So just in this case, we will just use the inside. I'm not sure what is the reference. That's the point. That's why the drawing would have been very interesting for this.
Yes. Anyway, we don't have complete drawing with geometrical tolerances because it was done with by one of the students. So
yeah, it doesn't matter. So okay,
so we can use the. I mean, logically, it would be to use the bottom surface.
Yes.
As a reference plane, but right now it is not. We can't touch the bottom surface.
So and this is now the problem why we usually have a lot of things where we just not really able to measure parts, because half of the application task for the measurement is how to fix the part that every position can be reached and so on.
Okay.
Yeah, this is a very big part, piece of our section of our work, is how to reach all the necessary measuring points.
But in principle, let me ask you: could we take this bottom surface? Because this is now accessible.
Yeah.
Could we utilize this bottom surface somehow as a reference somehow?
Yeah, that would be possible.
Because this we can access.
Yes.
So let's try to do so.
Yeah. So in this case, we would go first for centering.
for centering, so that would just center it. Okay.
So, and then we would go inside and center the inside the board to make it align it.
Okay, you mean use this inside pore for alignment?
Yes.
Okay, so let's do it. Maximum eccentricity 5 is okay.
Yeah.
So measuring height now. Should I try to go inside the board?
Yes. Yeah.
I will try to. There is a nasty surface here, but let's see what we can do. So I would take this as a measuring height.
So then we will go for the measuring range to make it 1. Yeah.
First measuring range 1. Measuring
height. Yeah. And the radius is also, you can see now that the radius is minus. Now we have the right position, because now the calculation of the points is correct.
Okay. Okay. And actually, I mean, right over there, it still stays range 2.
Yes, that's right. But this is the actual position of the machine and the actual setting of the machine. If you, as soon as you press start, everything else from you entered from above will be just taken.
Okay, I take start. We go.
And now you see that the range was changing to 1.
Exactly. Let's see what we can do here. It is. Okay. Actually, it's not good. I mean, we unfortunately we can't use this pore because it is of very bad quality. I'm not sure how well you can see it from the camera.
Not really good, but yeah, I can imagine. So
let's try to use this one.
You can also go outside, yeah. So then
let's try to use the outside one. Do I need to change something for that?
Yeah,
No?
I would probably cancel.
Let's cancel this.
Cancel because we pressed already start. So now we go to the right position and
we go out there.
Yeah.
And take the new height. Because I have also changed the height. I will change it to this one. And now it should be okay.
That's right.
And I can start it. Okay. Let's now we work on the x-axis. Like this.
Yeah.
And then on the y is really off. And it is within the given tolerance.
Yeah. Okay. Good.
I could add it to multi-feature if I like.
Yeah.
But this makes only sense if I would like to repeat these measurements. Yes.
That's right. Yeah. So as long as you don't really want to, then but it doesn't hurt. So yeah.
Let's do it. So we have done it.
Yeah.
We have centered it.
Yeah.
I don't know about the tilting now. Is it?
We could also go for the tilting, and but this will also affect our centering again.
Okay,
Because
so,
the centering is mostly independent from the tilting, but the tilting not. Yeah, because if you just change the angular position of the table, then of course, according to depending on the height of the part, the center we just or the circle we just centered will just also move with the angle.
okay.
Yeah. So in worst case, so for the full automatic machines, I would probably go for center, tilt, and then center again. So, but here we have a manual machine. We don't really want to switch the probe manually and move forward and back. So it's too much effort for my opinion. But if you want to do it really right, now we would go for the tilting, then again for the centering.
Okay, but okay, let's do it. Let's see how much time it will take. So let's check.
Okay. Tilt, yes.
Everything.
So in this case, we would just so we want
inclination is too much. Is it 50? It's too much.
Yeah, just watch for the units. This is 50 micrometers per meter.
Okay.
So now what is the diameter of your workpiece?
Roughly 100.
100. So that would be 5 micrometer on this workpiece.
Okay.
Yeah.
That's actually okay.
That's actually okay. That's what I also think.
So measuring height.
So 1 second, we just have to be careful because we need to switch, move our probe into horizontal position because we want to touch the part from top.
Ah, okay. You mean from this one?
Yeah.
Okay, now I see.
Or from below, whatever.
So we go and
so
change.
You have to decide what you want to get a reference from below or from above.
Let's take below. Let's try to take below.
Okay, then we will just go back. Okay, hopefully it will work. I'm not sure if the probe is, maybe the probe is too long.
Might be, yes. It actually is too long, I'm afraid. Because I now make it horizontal. Can I do it?
Yes. Yeah.
Like this.
Yes.
And if we go down, we see that there is not enough travel on the axis. We could try to do it the upper one, but there is a nasty burr. Exactly.
No, this is the problem. If you are interested in this surface with the perpendicularity or the reference to something else, you cannot use this for the alignment. So you just need to use the reference. If you have trouble with this surface, then it can be the reference for your alignment.
Okay, understood. So actually we can't do tilting. We can't.
Yes. And sometimes it works. Maybe you should consider to not measure this this part as a single part. Maybe you just measure it in a complete assembled position with the next attached part or something like this as a unit.
Okay, I see what you mean. Yes.
Yeah, then you can also get maybe a different reference, which is easier reachable.
Okay.
And next thing is you avoid to get some, maybe the problem is also the adjustment during the assembly.
Okay,
so
but
if you have a single unit, then you can also sometimes have to measure the units or the complete assembly because the process is giving you bigger tolerances than the part itself has actually.
I see. Yes, I see.
Yeah.
But in principle, I'm just trying to see if the probe in this position, if we mount it like this, it is, you see what I have done?
Yeah, but this will touch with the shaft
Yes.
on the chamfer. So probably you would have to go. Yeah, something like this could happen, that you have to go move around the part like this, and then now just move the z-axis more down, and the x-axis more to the right side.
Anyway, sorry, I mean, I was confused because actually from here we might be actually be able, you see, if I now change this, go down with a Z,
Yes, and then it's possible.
then I make it close to horizontal. Let's see.
Yeah, more, even more.
Even more horizontal.
Yeah, but the
Then-
next thing is you just
yes,
there's
that's
your
the
problem.
collision, yes. So that's bad.
That's bad. Yeah,
Yes.
that's always a problem with the machines.
You see, I'm still struggling with getting the axis. You see, it is doable. My bad. I'm not fully understanding the movement still. So
Yeah.
we can actually do it.
Yes.
Yes.
Good.
Good.
Fine.
Exactly.
So what we need to tell the machine that we just here on the software, on our software, once again, screen. So we don't want to measure from above. So under measurement, you see that the probe is touching from above, but in this case, we want to measure from below.
Sellega annab kõik so okay. So we want to touch from this one.
Yes, that's right.
So
and then the probe, yeah, we have to change the probe position.
This we should do.
No, in the we have to tell the machine that the probe position changed.
Settings?
Yeah, I guess so. Maybe there's something with settings. The measurement. Auto post travel. No.
Should I go to measuring station?
Measuring station, yes. That's right. So the probe.
The probe
control probe. So and then we just enter 90 degrees for the value, angle.
This one?
Yeah.
90. Like this.
One below. The value below. Yeah. Okay, enter. The machine will ask you to do so. Yes, we already did. Okay.
What is the mean? What does it HP? What does it mean?
This is the angle of the probe axis.
Okay.
And now you can see at the moment that so now you have the touching vector, the contact vector, and the left. Yeah. So it's just pointing upwards.
Okay.
Yeah.
Yes. Let's see if the deflection is right way. Correct way, the deflection. So for just in case, let's say, just as a scenario, in this position right now we are going from down to up, upward direction.
Yeah.
If I would like to go from the other direction, what I should need to change from the software?
We need to change the contact direction. Yes.
This one.
Yes.
Okay. So for now it's good. We leave it. I'm going to, how do I get out from here?
Press measuring station again, yes, and then we're back to the measurement, and now you see the 90 degrees. That's okay. And now we go for the measurement. And we could press start. No measuring height. Maybe it's I'm not sure if this is necessary.
Let's start and let's see
Yeah.
what will happen. Now I will need to contact the surface.
Yeah.
Is there also a fine adjustment for the C?
No,
No need.
not as far as I know.
Okay, click OK. And it is measuring. Oh, it's bad.
Yeah.
Okay, I mean, are we in a possible scenario where it will take us a lot of time to align it?
Yeah, could be.
Because
But,
I mean, this A is now at the end. It's, you see this A knob, it's at the end position, it's not going. It is actually not changing anything, so.
okay.
Yes. Okay, I will.
This could be that a problem of the radius around the turning point. So yeah, okay, just let's say okay, or cancel it.
Let's see what we can do. Let's see if I can do the B. But B is also.
Yeah, but here something is moving.
But no, it's also the knob is at the end position. It's not.
Yeah, then you have a slightly problem here, and so.
The problem now is with what? Is it with the part or is it something else? Or
could be the table. I don't know the table, so I would have to check the table myself to see if there's a real problem with the table. But this is something we can just say cancel.
okay. Yes, I mean, let's cancel it for now to save. And if needed, we can work on this later.
Yeah. Okay.
Somehow.
So okay, we also close this measuring task.
How do I close? How do
I can't see the right. So measurement. We will go go for selection.
Just for selection. Okay.
Yeah, and measure the next one. So maybe we just select plane.
Plane.
Plane, yeah.
Plane.
Yeah.
Okay.
No, this is the plane. Yeah, it would be plane for reference. That's right. Yeah, that's what we will do.
Datum plane. And try to measure the same plane.
Yes.
Okay, I will call it.
And just contact direction. Change the contact direction.
This one.
Yeah.
And start.
Start, yes.
Measuring range 1.
Yeah, definitely.
Start. Go in contact.
Yeah.
And say okay.
Yeah. It's a typical form.
Okay, let's add it.
Yeah. Good.
We have
now we go for the selection. Then we have this. What is this plane? There must be the
Flatness, you mean?
Flatness, yes, flatness.
Flatness measure.
And now we go for reuse.
Reuse.
Because we measured it already. How was it named?
Sorry, we want to reuse the last plane.
Yes, that's right.
Plane 14.
Yeah. Okay, start. No tolerance. We don't have a tolerance. So, and now we can see the plane, how it looks like. And it's a typical building. So, and if you just press the, you can use the mouse on the right side, on the graph, yeah, and with you can just click and turn it with and move it. Maybe you have to enter the right. Was the scale, and with the control button and right mouse button, you can also turn it usually. I'm not sure if this is already available in the version software version you have.
It is changing the scale.
It's changing the scale, yeah.
Scale, but it is not. It is not rotating.
Not rotating. Okay.
No,
so,
changing the scale only.
Yeah, maybe. So actually, you have the Marvin version 2, and we are actually at Marvin version 12. So it's a little bit outdated.
But what do you think? Should we consider an update? Is it possible?
Would be possible, but for the basic measurements you have there, I'm not really sure this is
No need.
Necessary. It's not really necessary. The basic function will still work, but you cannot see or use some of the new features. So.
Okay, understood. No point in doing that. Yes.
No really point in this. So if you would have manufacturing and you would daily use it frequently, and you would do something like statistics or something like this, then I would say yes. But in your case, I probably would not make an update.
Okay. Okay.
Yeah. So, and then we have the reference. Okay, add to the multi-feature, or just skip it, whatever, and we just measure
Axial runout.
We can use the Excel runout, yes. But in this case, the datum, we would have to use the spindle as the datum, because we don't really have, we didn't really measure the workpiece.
But let's say, for the sake of training, could we just go now and build an axis based on this surface?
Yes, that would be possible.
And use this axis as a reference? Would it make sense?
The problem is that the two circles of the axis are very close to each other.
Okay, I see.
And with the big deviation, I think this would be a problem with the result. Yeah, I wouldn't call this stable. Just to get an impression what is the thing, yes, would be possible.
Stable.
Yeah, and then measurement.
Measurement, okay, over there.
Yeah, so, and now we want to measure from above. That's okay. Measuring range is 1. Okay. So now we have to move there.
Okay. I need to.
Yeah.
To get off from there, I need to tilt the probe.
Yeah.
Then tilt it back to 90 degrees.
Yes.
Tilt it back to 90 degrees roughly.
Yeah.
And now we can come close to the surface. And actually we can start it, yes?
No, because we don't have the right contact direction. So we have to switch the measuring direction at the probe.
Ah, okay, okay. Measuring station.
No, not in the measuring station. This is fine because we select measurement from above. It means that the direction will be
Okay, you
changed,
mean
but
physical.
physically on our probe.
Okay, for
Yeah.
that. No.
Yeah, that's okay. Yeah.
Where did you saw that now?
Because the probe direction, the deviation, the blue bar was,
This one.
yeah, was always in still in plus direction. Means
Okay.
it's
So let me just do it one more time to show it.
Yeah.
So okay, it's okay, and now it's in the other direction.
Yeah.
Okay, and
so and just full to the end. So that's it's not completely at the end.
Yes. Like
Yes. Yeah.
like
So with this one, so now it's a full range, and if you just turn it just a little bit back,
yes, it's
then you have a kind of limitation, probe range limitation.
okay. Okay.
This is very useful if you just have something like a gap inside your measuring area, and you have, for example, if you have a deep gap and you have only a probe of 1 millimeter diameter or something like this, then you would have to change. Otherwise, the probe could be damaged when you just fall into the gap.
Okay. Okay. So now I can go in contact.
Yep. It needs charging.
No, it's in the wrong direction still.
Yes, you didn't change it. Yes.
I changed it in the wrong direction. It must be there.
Yeah.
Now
I'll be right back. So 1 second, my headset needs the charge.
no problem.
So, okay.
Yes. And now we start.
Yes. Yeah, okay. Okay.
Okay, yes, it is 0.1 millimeters.
0.1 millimeters. Okay.
Yes. Okay.
Yeah. Okay. Then add to the multi-feature, and we will just do the same. We evaluate the flatness of this surface. We want to see it again.
Selection.
Flatness.
Reuse.
Yeah. Reuse.
I will call it flatness 14.
Yeah. Okay.
Use, and use this
run out. I think run 14.1. Yeah. I guess. Yeah.
And start.
And start. Then we will see. It looks a little bit different.
It is somewhat better.
No, was it?
I mean, the value is smaller. That's why I said better.
Yeah, better than the run out, but better worse than the flatness of the opposite surface.
Okay, okay. So I will add it to multi-feature.
Yeah.
Flat 14 already. Okay, different
because
task.
it's on the opposite side. So then it's yeah.
Do I need to rerun it?
Yeah, start. Yeah, and it's okay.
Okay, now it's okay. Now I can add it to multi-feature, and here I can compare the values.
Yes, and if you now click on the other one, so you can also see the results. Yeah. Yeah. Always have a look for the scale.
Yes.
If you compare them, yeah.
or these values here.
Yeah.
These values I like. Okay. Okay, I see.
So, and then we have the next one. We have the selection, and we use the parallelism.
Okay, let's do it.
Yeah, and in this case, we use the datum. We use our
Flat.
no, what was it named? Axis, no.
For the datum, we need to use the what now?
We just want to use the surface. It's not possible here.
It's not possible. Yes.
That's okay. Because it just allows us only access.
Yes, it only allows access. Yes.
Okay, but yeah, in this case, 1 second. You just have to switch the measuring direction. So the measuring direction here is from radial. The contact direction should be plane.
So I need to go to measuring station.
No, this is okay. The below parameter task. Yes.
This
and
one?
Then yes, click. Yeah, and now you have also the
Flatness is
yes.
Let's say, where is it? Because we don't
must
have
be
it.
plane.
We have plane, yes. The plane.
Yeah, I think plane 14 was it.
Exactly,
Yeah.
yes. I have
So
it.
now the measurements. Now measurement is a reuse. No, reuse. We can reuse it. So, and then we have the upper plane is run out. No, it's not run out. I'm not sure of the name. I think a run out. Yeah, that's fine. The first one.
The first one.
Actual run out. Yes. Add. Yeah. Okay, and start, and we will see what's. Oh, yeah.
Wow. No.
The problem is you will get a linear. Yeah, but what is this? How much is it?
It's close to 200 microns, the value.
Wonderful.
Yes. 0.2.
Yeah.
Okay.
Yeah.
Okay, anyway, let's be honest. I mean, this is not the perfect part anyways.
Yeah.
I think that in principle, we got an idea how to conduct these kind of measurements.
Yes.
Do the evaluation.
Good.
Can I change the scale here? So let me try to.
Yeah. So.
Okay, so if I do it like this, then it is changing. But is there some other means? Let's say if I want to switch from micrometers to millimeters on the graph.
No, you always have to you can change it with the scale, but nothing else is really useful there. So
Okay.
as soon as you are coming in the range of millimeters, the unit will automatically change.
Okay.
Or should change.
Okay, now we have a scale roughly 50 micrometers.
Yes.
If I count the difference, 1, 2, 3, 4, yes, it is 200 microns. Yes.
Yeah.
Okay. And so the blue, okay, yes, the blue lines, these are kind of the plane representatives of the planes we measured.
Yes. Yeah.
The upper one and the lower one.
Yes.
And then this black one would be the profile of the upper one.
Yes, that's right.
Okay.
And the x-axis, the horizontal axis, would be perpendicular to the z-axis, would be the plane in
Yes.
yeah, of the
Right
machine.
now, it's a kind of rotated 90 degrees in
Yeah.
the physical
Yeah.
part. Yes. Okay.
Yeah.
Okay.
Yeah.
So actually, I mean, I don't know. Is there something else here we can do?
It's almost the main things. We would be able to make something like calibration of the probe if you want to measure something very exact. So, and you should calibrate the probe. But now is the big but. As we don't know the probe angle, you would have to do this always when you just measure the change the probe angle, because the sensitivity of the probe is depending very much on the angle, and we don't know we are not able to adjust the angle accurate enough to change this.
Okay.
So just to make a try what this means, where if you just change to the measuring station.
Measuring station.
Yes. So and then the control probe. So now we are at 90 degrees.
Yes.
So and now you see that U and V, they don't have any vectors.
No.
And now you change the probe angle to, let's say, 80 degrees.
Roughly 80. Yes.
Yeah. Just enter. Yeah. Okay.
And
Confirm.
also switch physically.
No. Just for the demonstration, because this is a yeah. So and now you have seen that the U direction, there's a part of the U direction which is usually not really calculated, but also in our W direction, the value changed from 0.99 something to 0.98. So this is a difference of about 2%.
Yes.
So and means if you just have a deviation of 10 degrees from the nominal, you could already have 2% of the variation wrong. So means if you have a flatness now measured with 90 degrees, but you don't really have a 90 degrees, then it could be your result 2% too high or too low.
Okay.
So the same would be now also for the just if you enter 0%, 0
Over there, 0.
Yeah.
As it would be vertical.
Vertical, yes. Press enter. So and now you see here that the value is 996, and now you enter 10 degrees. Yeah, enter. So and then it's 981.
9.
So and this means also that you will get slightly bigger result than it actually is. So
okay.
yeah. So the sensitivity is always in x-axis or in z-axis is depending on the angle and the deviation of the entered angle and the real angle.
Okay, and let's say the conclusion from here is that what should we take it from there? Sorry, I'm not fully grasping it right now.
Yeah, if you want to get very accurate result for a roundness or something like this, yes, then it's recommended that you go in the workstation to no, it's not in the workstation. I guess it's just deselect workstation.
I will close the measured.
Yeah, yeah. Could be in options. Is there options?
Yes, there is something called
Measurement deviation graphics. No, this is cancel. Maybe again in the workstation. I will just have to switch for it myself. It's not so often used. Probe system. Go for probe system, and there you can calibrate.
Okay, this one.
Yeah, if you calibrate, then you can calibrate the probe sensitivity, for example, against a workpiece or something like this.
I don't know, let's not do it. But okay, I would still recommend, let me get a caliper, a ring one.
Yeah.
Try to measure let's try to measure the roundness of this caliper.
Okay, yeah.
Okay, viitsid anda sellest seal kohvris üks väike, vaata, mille me saaksime siia vahele tõmmata. I'm closing this one.
Yes, of course.
Also this measuring station. Let's have a new measurement. So I'm speaking about like this one.
Yeah, of course.
Because this we should be able to clamp it, and let's see what we can get. So new measurement. We are not saving the ones.
Yeah.
No,
okay.
No need to save it. So we will attach it here. And let's try to perform let's check this one. Läheb üldse nii palju kokku, et ülemist küll ei ole, läheb ikka vist. Yes, so it's clamped.
Yeah.
And let's try to do it from the beginning. First, obviously,
yes.
This one we would like to just center it.
Yeah.
Measure the roundness, for example, just centering is fine.
Just centering is fine, yeah.
So let me choose centering.
Yeah.
Obviously, the probe is in the wrong direction.
Yeah. So we will just have to set it to the right direction, and we have to give the system also the information because the probe is officially at 10 degrees.
So we go to measuring station, control probe. Actually, it is 10 degrees is not bad. Actually, with the
okay, then just you can leave it like this. So this is
so
fine.
it is roughly. Yes.
Yeah.
Roughly 10 degrees of angle. So we leave it as it is. Only okay. I close the measuring station. Now I need to physically, because the measuring direction is actually wrong. So I need to physically change the direction so it can be touched from this side.
Yeah.
Okay, now I mean, yes, it's hard to show. So it should be all set. Center, I will call it 15. Now we go to contact with but is it okay to center it with the surface we are going to measure, or should we consider centering it with the outside ring?
No, inside. In this case, outside is meaningless because this is not a functional surface.
Okay. So we go like to this direction roughly.
Yeah.
Over there. Measuring range 1.
Yes.
Contact is correct.
Yes.
and I should start.
Yeah, measuring height is probably also needed, but this is, yeah, okay.
And start.
Yes.
Measuring force direction to 1.
Yeah.
So please change the measuring force direction to 1. This is now indication to this black knob.
Yes, that's the system is believing that the measuring direction is still wrong, but we already changed it, so we just click OK.
And we can go and try to. And let's measure this for the centering. So it was already actually quite good.
Okay, lucky.
Yes. So I mean, most probably the table was still in the correct position from the last measure. Yes.
That's what I also think. Yeah.
Yes. Okay. So I will add it. Okay. And now I go to selection and roundness.
Yeah.
And in principle, I can reuse. Or
yes. Always be careful with reusing centering and tilting items, because it could be that these are not the latest ones. Means
so
if you just move the workpiece after the last measurement of the centering and tilting, then these are not the actual values. So I would always try to avoid something like this.
So let's avoid it. Let's make a new measurement.
Yeah.
I'm actually going to set a new height.
Yeah. And probably I would also change the measuring range now.
The measuring range to more sensitive one.
Yes.
And this we can actually start now.
Yes, I think so too.
And click OK.
Okay, that's right.
So this is really nice result.
Yeah, that's something I was expecting for gauge quality.
Okay.
Make the polar centered graph.
Polar centered.
So, and then just have a look on the scale. This is always important.
Yes, we see it's 0.5 microns, so it is nothing.
Yeah, 0.05. Yeah.
0.05 exactly. Yes.
Yeah.
So
that's typical.
It is so small. It is hard to imagine.
Yeah.
Okay. I mean, this was all clear. Anything else we could do with the gauge now?
No, for the gauge, there's not really much you can do. At least not with the machine. So this machine, with an MMQ100 or 400, I would have said, okay, you can make a cylindricity or something like this inside. But this machine is not built to do this.
This we don't have cylindricity.
Yeah.
I mean, just for how to say, for the learning purposes, could we try to do concentricity between the inner and outer circles?
Could be, yeah. But with this surface outside, so it's meaningless. So this is something you could have done with the other disc part, from the inside diameter to the outside diameter, or from the Where's the disk?
This
Yeah.
I also have. I mean, this was the disk.
Yeah.
This was the disk, but there is another problematic part sent to us. I mean,
Yeah.
this is already. I mean, unfortunately, this is a scrapped one.
Yeah.
But this is an assembly.
Yeah.
You see, few of them.
Yeah.
So in principle, we could do concentricity because this is a turned surface, and also this one is a turned surface.
Yeah.
But here we run into problem how to attach it right now because our fixture, this what you call vice.
Yeah. The chuck. Yeah.
Is
too small.
Efficient, yes.
Yeah. Sometimes if you do you have a thread inside or a hole?
There's a thread, yes.
Yes. So sometimes we use simply a screw and clamp the screw.
Okay, so we screw it and then we can clamp from there, yes?
Yeah.
Okay, this is actually an option. Let's see, because if I should have a... No, I don't have it.
That's the diameter is a big one, yeah.
Okay, but let's say with this part, you see we have 2 diameters.
Yes.
Let's try to clamp it. I don't know, it's still too big. I mean, we could have checked the concentricity, but I have some demo pieces here from previous. This is a kind of a demo piece that we have.
Yeah. Okay.
I mean, also, as you said, it might be kind of meaningless because this surface is not turned.
Yeah, this is usually so we have some to explain something about concentricity. Concentricity is only possible when both measurements are at one plane. Everything else is a coaxiality.
Can you elaborate on this? What do you mean?
Yeah, the problem is when concentricity means that both circles have to be on the same level.
Okay.
So this is really only possible if you measure from inside to outside.
Okay, you mean like, for instance, we take this small edge from here.
Yes, and to the outside.
From outside and inside.
Yes, then that would be concentricity on the same level. Okay. So everything else, as soon as the 2 circles you want to compare are not on the same level, then these are coaxialities because you have an axis, you have to extend it one circle in somehow to the level on the other circle. So either you will take the center point of one circle and the z-axis or c-axis of the machine to create an axis, and then compare the offset between the center point of the measured circle and this axis, or you will just have to measure 2 circles as an reference axis and then make the coaxiality to this axis.
Okay.
Yeah. If these two circles are not on the same plane, you always have to you have to calculate the offset between the 2 center points somehow. And if they are not in the same plane, so how will you calculate it?
Okay, but it still I'm a little bit confused. For example, if we look at the gauge now.
Yeah.
Let's say we still, let's say hypothetically, we want to elaborate the concentricity between the inner diameter and outer diameter.
That's okay, because they are on the same level.
Okay.
So if you just have the first part we started with.
Okay, and you mean,
yeah,
with this surface and with this one, that is already coaxiality, yes.
This is coaxiality, yes.
Okay. Okay.
Also, if you would try to compare the outer diameter from the lower part section to the inner diameter of the bore, this is also coaxiality.
Okay.
Because it's not exactly the same level.
Okay, I see. So let's think what we can do further now.
Well, we can just use the first part and make the perpendicularity.
Okay, why not actually?
Yeah, this is the only thing that is really left. We can just try right away, and that is easy to do.
So let us see how we can fix the part the other way around. Yes.
Yeah. Yeah.
With a gauge. It's on the gauge. I mean, the problem for us is we would need to clamp it like this.
Yes.
That is now the problem. That is now the problem because no, actually, let's see. We can do it.
No, this is not really a problem. If as long as you can get it inside, then it's fine.
Let's see. Should.
Mm-hmm.
No, I mean the chuck is not sufficient.
Yeah, I see what you mean.
Yes, that is the problem. We can't clamp it. We would need to change the direction of the jaws.
Yes, that's right.
So,
but just put it on top so we can discuss it. Yeah. So, if you have a long part and the axis length of your z-axis is not long enough, then you have a trick to extend the measuring range of the machine. So you can use the probe and not in 0 degree or in 10 degrees position. You can also use it in 170 degree position.
Okay, but anyway, sorry. So I have found this piece. Actually, it is also something that has been on the table as a problematic one.
Okay.
You see, it's a kind of a shaft. So I would suggest we try to inspect this.
Yeah.
Let's say this is a kind of a bearing surface.
Yeah.
So let's use this one to build our reference, our data axis.
Good.
And then we can evaluate the coaxiality of this part.
Yeah.
And also the perpendicularity, because this is also
on top.
A machine surface.
Okay.
And perhaps, yes, we can do some other things as, again, the roundness and let's see what we can measure on this one.
Yeah, okay.
There is a thread here, so I can attach it here.
Yeah. Can we clamp it higher?
Yes, we can do that.
Yeah, if possible.
So it is, we think it is a little bit. So
I think this is too much.
This is too much, okay. English, please.
But how do we know if the chuck is aligned perpendicular and square?
Küsib eesti keeles, see pole oluline, selles mõttes me hakkame teda joondama praegu. See laud liigub. See on nii-öelda XY lauda. So we would need to go like this. I mean, it is
okay, that's fine.
As good as it gets, but anyway, I mean, all these features are accessible. Or
that's fine. Yeah.
So let's take it from here. So first, center and tilt this time.
Yeah, so one I just sent one thing in the comments. We have an app to explain the tolerance symbols.
Okay, as a smartphone app, yes.
Smartphone app, yeah, for the I'm not sure, probably it's also available for iPhone.
Okay, so it's called something like or if you search.
MahrMMQ100, yes.
Okay, the students have started downloading it as we
Okay, let me see. Check the numbers of download numbers.
Yes. Okay, so let's start. Center and tilt.
Yeah. Center and tilt. Maybe you select first new, or is it already a new program?
No, let's take new one. Yes.
Yeah.
Now it's new, center and tilt. Give this a random name 155.
Yeah.
And oh my God. And measuring heights. Okay, let's establish them.
Yeah.
So first I will generate the higher position. Or I understand this is actually not important in which way we go.
That's right.
Measuring height and then the last height.
Yeah.
Over there. Like this. Measuring range 1. And the direction, probe direction should be okay.
Yep.
Also the probe angle is okay.
Yep.
So we can start.
Yep.
First we go to upper position. 82. And click OK. Go to contact.
Yes.
Okay. Measuring the first reference. Now go to 71, was it? Okay, a little bit up like this. Okay, measure it. Okay. The question still bothering me a little bit because I'm not sure if I quite get it. Was this probe angle? Let's say, for instance, right now the physical angle is actually close to 10 degrees, as it says over there.
Yeah.
But let's say if it says there 10 degrees and physically it is roughly around 45. So
yeah,
will this be problematic?
You will get a higher roundness result.
Okay, so let's say the rule is that the physical and this they should be similar.
Yes.
Okay, so now we need to adjust it. The centering.
The explanation for it, the probe itself is not detecting a movement in a certain direction in an axis. The probe is detecting the angular movement of around the probe axis.
Okay.
And if the probe is touching in a different direction, then the working length of the probe is shorter.
Okay.
And but the system is calculating with a longer one. Means that for making a movement of, let's say, 2 micrometer at 45 degrees, you will need an angle which this is comparable to about 3 micrometer movement of at 0 degrees.
Okay. Okay. Yes, it makes sense in general. I understand. It's a detail you need to work out. So the white one. The white one is
yeah, now it's moving.
yes. Okay. Okay, my bad. I didn't move it. $82. Retry. Tõmbasid läbi all või? Jaan. So the first feedback is that the app didn't start. iPhone, Android. Okay.
iPhone üks asja tegema hakkas.
I rarely use it, so I'm not sure. So I have it also on my phone. 1 second, let me check. Yeah, for my phone it starts. So
Okay. It must be the phone.
yeah, well, maybe. Maybe only for customers and employees. So I
nii palju inakeelt. Just selle lasemas. See inakeele ei ole midagi. Okei. Küll on juba lahe, 5 inakeelt õppida. Hääldada mingi keskpäega. Maasa sees. Aga see on standardiseerimise jaoks väga hea. Ilusad liikud pildid. Tegelikult tsentraalne kriteeriumisse. Igal pool vaja.
On see tõmbasid nüüd ära? Maar mis? MahrForm või?
MahrParameter.
Worked on my iPhone.
Oh yeah.
It seems that if you search the Google Play for just Mahr, it gives you 2 apps.
Yes, that's right.
You have to download the MahrParameter app, was it? Yes.
Yeah. Good.
See liikud pildid on vaatad. Lahe. See mida ma seda joonist koostamisel on täiesti puudutanud. Ei tea, kuidas teha. Las failist kõik peab õige olema.
Okay, it takes
samaski meetri vastu erinevust, mida siin okei, C, see on see koht, kuidas null.
So it could be that the table, the tilting is a problem on this height. So there is what we say a tilting neutral level somewhere above the table, because that's not a simple rotational joint. It's just something like a 4-joint movement.
Okay.
see on lappes, noh.
Millalgi te praegu otsustasite seda?
Silmaga. Veidi ovaalne oli. Ei, tal on tensus on tal.
If this is still too bad, then just make the upper circle on the upper cylinder, and then we will just align the part completely, and we will make a reference axis only on the lower part.
Okay.
Which is mostly much more efficient.
Okay.
So cancel this and then change the upper position to the upper. Okay. To the upper cylinder.
Let's take it from somewhere from
yeah, that's nice.
Okay, and change this one, yes.
Yeah.
I will physically write there this value.
Yeah.
And we start again, yes?
Yes.
Pakid sentri on paigas, siis on selle teile paika pilved.
Oh, red one. Okay. Green one. But could it be that it is there is so much tilt already here because of holding from thread that we are actually not physically capable in aligning it with this table?
No, you should get to the limit when it's end, or it should be stable. But there is probably nothing in between.
Okay, let's.
I see that the alignment of the tilting is done at the lower position. We should change this to upper position. Change these two position that when we do the alignment, we are in upper. We have a longer access to see the movement of the angle.
I'm not sure if we did understand now.
The position where you measure with the probe, we can only move detect horizontal movement. But this the horizontal movement for the same angle is in the upper measuring position bigger than in the lower measuring position.
Ah, okay.
Yeah.
Because of the differences in diameter.
Yeah. No, not of the difference in the height and the distance from the turning point.
Okay.
Yeah.
Okay, but anyway, now I will continue.
Okay. Yeah.
Because it is not looking promising as.
Yeah, also for me, it's something strange that you always need so much to turn on these A/B knobs to make a movement at all.
Okay. No. Yes, I'm turning it quite a bit already.
Yeah.
And the numbers which were smaller, they tend to get back bigger again now. We were, let's say I had to.
Yeah.
So something I am not understanding here right now.
Yeah. The problem is that the turning point is somehow something above the table. And if you are very close to the turning point, it's the detection is very difficult to do. So that's why I think we just should make the second measuring point at the upper point.
But are we this? I mean, this is what we are doing. The upper point is here.
No,
yes?
No. When you are contacting to correct the tilting, then you are at the lower point.
Okay, but how do we change that?
Just change the values.
Okay,
Just
I
put
will,
71 in the measuring height and the last measurement 130.
so I will cancel it.
Cancel, yes.
Cancel, okay, and let's say this one will be 70,
Yep.
and this one will be 150.
Yeah, if it's possible. Yep.
And let's try to do it.
Yep.
So okay. So now what you said is that this point, this lower one is now it is closer. Is it so
Yes.
to the pivot
Yes.
point of the table?
But when you adjust the tilting, then you should be at the upper point, because it's more away from the turning point of the part when you just make the tilting correction.
But right now,
Yeah.
right now it's correct, but right as you said, right now we are making the adjustment around the higher point.
Yeah.
And it says it is the last height.
Yes, that's right.
Okay. So it is always the last height around which the adjustments are made.
Yes.
Okay, okay, now I get it.
The axis to calculate the correction is done with both points, but the adjustment with the values you see now with the scale and so on, this is done right in this position.
Yes, okay, yes. The values are still. mul on see asi siin kinni ikka vahele. I hope it is fixed still in between the chucks.
Samasega ta mingi väga survet ei avaldatud. Kui jõuda su pehmet kinni, ta ei tohiks enam loperdada. No, ta teeb survet lihtsalt.
Yeah.
Oh.
It could be that your table is not so good anymore. Then this could explain the reason why you turn 4 and back.
Let's see. But I mean, this machine, it hasn't been used very much, so.
Yeah, but can only happen that someone is, for example, just pushing it too far into the limits, and then it could be damaged by this. Yeah, just an idea. So I'm not sure.
Let's see. I have some hope that it will, and if not, we will take another part.
Yeah, but we will see.
Okay. Okay. At least they were both green. Perhaps we should lower the 5 micron value, no?
No, raise, then it's more tolerant.
Okay.
Because the 5 micron is the upper limit for the both eccentricities.
Okay, one more time, but I think we are getting closer because the values are smaller.
Could be, yeah.
I mean, what I mean here is that not so much adjusting for
Yeah.
the last this adjustment.
Okay, could be.
It was quite close to green already.
Okay.
Let's see. Whoa! Finally, we have it.
But you see that you started with almost 0.5 millimeters, and then you came constantly down a little bit.
Absolutely. But what could have been there? Is it that is it the thread below the part that was?
No. If the thread is the problem, then the part would be not really fixed. It
Okay.
means that the part is just moving, still moving. It's not really fixed clamped. As soon as it's fixed clamped, it doesn't matter if it's a thread or whatever underneath.
So because I mean this one, it was already good at the beginning. Yes.
Yeah, but could have been lucky.
Okay. So at least we are here and we can proceed. So we have done the center and tilt.
Yeah.
Now we would like to establish the referent axis.
Yes.
So datum axis.
Yeah.
Can
now
we
do 2 circle measurement at the lower, at the bigger cylinder.
2 roundnesses?
Yeah, circle measurement. Yes.
Roundness.
No,
Yeah.
no. We want to make the axis. We could also make two roundness and reuse them to build the axis. Or you make the axis and use both circles to re-evaluate the roundness. This is as you like.
But no, please tell me, what was your first suggestion?
We can now measure the roundness 2 times on the cylinder.
Yes, on the lower one.
And then, on the lower one. And then we will just build an additionally an axis out of these 2 circles.
Yes.
By reusing them. Or we build an axis with measuring 2 circles and then reusing them to evaluate 2 roundnesses.
Okay.
Either other way is totally equal for the result.
But anyway, right now, the only way to proceed would be to use the roundness selection.
No, you can also go on with the axis first.
Okay. I see.
Doesn't matter.
Okay, so I take axis name.
Yeah.
And now number of measurements 2. The measuring heights. Let's use the measuring height like something like 85 should be okay.
Yeah.
And last height again 70. Yes.
Yeah.
Should be okay. Measuring range 1 should be okay.
No 2 in this case, because the alignment should be good enough.
Okay, we use the finer range and we start.
Yeah.
So first go to 85, which is, it's a little bit too high. Can I cancel it?
Yep.
And change it?
Yes.
We should change it to actually 80.
Okay.
It was too high, in my opinion.
Yep.
To be on the safe side, we change it to 80. And then we start again.
Yeah.
Now it is close here. Okay,
Yes.
contact.
Yeah.
Fine adjustment. And okay. Then we go manually down to we okay. Oh, my bad. Can I stop it because it is not in contact? It didn't ask me. I wasn't. So let's do it again.
Yeah.
AD.
1 second.
Yes. Axis created at the multi-feature.
Yeah, wonderful.
We have axis.
Yeah.
Now we can try to evaluate
Roundness, yes.
roundness. We can do from reusing.
Yeah.
Can we now we need to choose which one we will reuse or
Yes. Axis 155.
axis, the axis, this one. Yes, add and
And
stop.
you can also evaluate both in one.
Okay.
The second one also edit.
Okay.
Yeah. Then you have two in one evaluation.
So sorry, what do you mean?
The second circle of the axis. Axis 255 underbar 2. Select add. The second circle.
Where?
The axis 255 underbar 2.
Yes, this we have chosen already.
Yeah, but you haven't added it.
It's over there.
Yeah, no, this is one. The second one.
Okay. Sorry. I didn't.
Yeah, so.
Yes. Sorry.
Yeah.
Okay, now we have the two measurements from that generation.
And then we can just select start. Polar centered. So, and then you see that you have individual results for each circle. And then you have the overall roundness is the worst case. It's always the worst roundness for all. That's this.
So in general, we can say the roundness is quite okay. Actually, it is 3000s, which is quite good.
Yes.
In our understanding, at least, with our standards, let's say.
Yeah. Okay.
Because this part, actually, we have turned it here on our CNC lab with the students.
Yeah, that's okay. That's definitely okay.
Definitely okay, I would say. Now.
So what you can also, if you want to get better results, then you just go for the your multi-feature.
Multi-feature,
Yeah, just edit.
edit.
Oh, we haven't didn't add the roundness. Sorry, the roundness was not added.
Okay.
Cancel. We have to do the roundness again.
Selection, round,
Yeah, roundness.
call it
Reuse.
reuse, both
Okay.
of these.
Both of them. So and just
Start and add to
yeah.
multi-feature, polar centered,
Yes.
add to multi-feature. Yes, it's there.
So now we go for edit.
Yes,
Yeah, and then we just go for the settings.
settings,
Yeah, and then evaluation.
evaluation.
So and now we have filter. We never played around with the filter so far. We can just make it better if we just go select filter 15.
50.
15.
Yes.
Yeah, okay, apply. And now we have a better result.
Okay. And
Yeah.
what did we now do effectively by changing filter?
We try to eliminate surface influence. And this means if you just have a measurement, you only want to see usually the form deviation. And you
Yes.
don't really want to see the surface roughness.
Yes.
And to eliminate the roughness, you will just or mostly use a filter.
Okay.
If we can edit again, if you just want to see the complete profile, we can also switch off the filter. Then the result is getting really, really bad. Yeah, evaluation. So bandpass, no, we just want to switch off the filter. No filter. The last one, filter type.
No filter.
No filter. Okay, apply. Now we have 7.45
Okay, yes.
micrometers. So that now you can see that the value really is depending also from the filter. This is always important. If you read a report, that you just always have a look on also the filter. What is telling this? Huh? So I could, with the filter settings, I can now change the result for the roundness from 7.5 down to 1 point something.
Exactly.
And this is a really, really big difference.
But let's say, what is the most common practice if we speak about the form measurement?
Form measurement is usually 50. That's what is the preset value.
Like this, yes.
Yes, if you have Gauss and 50. If you have a big diameter, you will go to 150, and if you have a huge diameter, filter 500.
Okay, but this is all standardized, as I know. Is it so? Yes.
Not really.
Okay.
The steps are standard. So 1550, 150, 500. These are standard, but there is no clear rule to set different filters for different parts.
Okay, so let's leave it as it is.
Yeah.
And apply. We are quite happy with the result. And let's see what else we can do with this part.
So now we have an axis, we have the roundness, so we can measure the upper cylinder.
Measure with
either we can just make a run out, we can also make a total run out, for example.
By total run out, you mean what?
Total run out is the run out of the complete. I'm not sure if this is available here. Oh no, it's not available.
No,
We don't have it on this machine. It's only run out available. Okay, in this case, we could make run out.
So we could make run out. I choose it, and then we would need to go and measure a diameter from the upper cylinder.
Yes, that's right.
Okay, let's do run out. Just call it somehow. We need to use the axis we have created as a reference.
Yes.
Then we go to measurement.
Yeah. So-
Measuring height, I can.
Yeah, and in this case, we want to measure, let's say, two circles. Then we select some of measurements, and if you select more, then we have two, the start height, the end height, and the measurements in between will be just in equal distances.
Let's try to do 3, just as an example.
Yeah, fine with me.
But there is no third. No.
This is fine. This is fine. That's what I just said.
Okay.
Second, the first and the last measurement is always given, and the others in between are just spread that you have equal distance in between the measuring levels.
Okay, so now I will set the height for this lower portion. For example, over there. Then we can set the height.
Just change this one to, let's say, 98. Manually 98, yeah. And the last one, just go there and to read it.
150. As it was where we did the line.
Yeah. Okay.
Okay. So now we can start.
Yeah.
Measuring range 2, just in case, and start. Manually do 89. And go and measure. Now it wants to go in between. 100.
Yeah, genau. Yeah, yes, you can just calculate it. That's 115 plus 98 divided by 2.
But it actually is telling us.
Yes, exactly it is.
So that's good. And now we go and have the last one. Okay. Okay. So there we have our 3 measurements, and also the run out is also, in my opinion, very good.
Yeah, I think so too.
5 microns.
Yeah. This is complete. That means the eccentricity and plus roundness. Yeah. Okay, that's good.
To multi-feature.
Yes, and now we make the roundness for all 3.
This we can do by selecting roundness.
Yes.
Let's call it something very special. And then we can reuse, yes?
Yes.
We can reuse all of the run out measurements we made.
Yes. Yeah.
Run out 1, run out 2.
So if you just click on it, it's automatically, after you click on add, you don't need to select the next one. You can just press on add again.
Yes.
So if you just select the first one, you just need to click 3 times add, and all 3 are added.
Excellent. So just out of curiosity, I will add a tolerance value here. I don't know.
2 micron.
Yes, 2 micron.
No, yeah, okay.
Okay,
Yes.
and all the roundness is very good.
Yeah, and then we select polar centered. So, okay.
Okay.
Yeah.
So this we have done.
Yeah.
I mean, just not to waste time, but I'm having difficulties. Not okay. Should we try to evaluate coaxiality? For that, we would need to build an axis for the upper
No,
cylinder.
we have already the axis. We don't need to change this one. We can just simply go.
Okay.
Coaxiality. Yeah, we have
Yes.
the axis.
We have the reference axis.
Yes.
Oh no, but
We have the reference axis. Yeah. No, this is the profile. We just want to.
yes,
We have already a final calculated axis. Okay, we
this is the
just
one.
add it.
Yes.
Yes.
Add this one.
Yes, and then we go for reuse and select our 3 circles.
Okay, so we don't need to build a special axis through the 3 circles.
No.
Okay.
So
we take these circles.
Add.
Yes. And start.
And start. Yes. So
it's okay, I think. There's some 5 micron difference, but polar centered.
Yeah, for me, this looks like that the axis of the upper circles is not exactly parallel to the axis below, and that's why the center point is getting more and more distance to the axis.
Okay. Okay.
Yeah.
Add to multi-feature. So, and then we would like to let's see, we can, in principle, we can evaluate the straightness of the upper part.
Yes.
Using the circles.
Yes.
Let's do it. Just as a exercise.
Yeah.
Reuse.
Yes.
Find the run out. Measurements. All 3.
Yeah.
And start.
Yeah.
Oh, it is at least the upper part seems to be rather straight. It is 0.1.
Yeah, it's a little bit tilted to the lower cylinder, but it's straight in itself.
Okay.
Not like the banana of the first part.
Yes. After multi-feature.
Yeah. Yeah.
And then let's try to evaluate the perpendicularity of the upper surface.
Yes.
And because now we would need to measure something.
That's right.
Yes. To evaluate perpendicularity. So please guide us.
Just simply we select the datum, we select the measure axis again, axis 155.
This one. Yes.
No, once stop, we will just remove the axis, just select and delete, because we want to make the perpendicularity out of measurements from above. That means now we would just have a plane as reference, but we want to use an axis as reference. So no, below the task name, there you have the contact directions.
Yes.
So this is a radial contact.
Yes.
Means that we will have the axis, the x-axis, or the flat plane as reference. But we actually want to have the axis as the reference and take the measurement on the plane.
Okay, this one.
Yes. So now it was changing the available elements was changing, and now we have our axis there.
Yes.
Yeah. So now we could go for measurement. So we just need to go a little bit higher and move the probe to 90-degree position.
We're
Also in the monitor. So this is the physical movement. Yes.
And now I have to go to set measuring station.
Yes, that we need to tell the machine that we move the probe.
Control probe.
Yeah.
Type in 90. Enter.
Yeah.
So, and that's
okay.
that.
Yeah, and what we also need to do is just to select the probe contact direction. At the moment,
So
it's touching up.
Now we need to change it from there.
Yes. So.
And this is now called probe contact direction.
Yes.
Probe contact direction. So measuring station.
Yeah, 1 second. If you just go in the measuring station again. Probe control, yeah. So you see then in the lower left corner of the window that the machine believes still that we're contacting up because we didn't tell the machine that we changed the direction.
Okay.
So right above is the contact direction. You see plus or minus.
Okay.
Yeah. Yes. We did already, and now the picture is fitting to our real situation.
Exactly. So this is okay.
So we switch off the monitor, and now we can just program our measurement on top of our part.
So in a way, we just go into contact.
Yep. So if you want, you can enter measuring height Z and radius position X.
Well, do they have any significance? Are they important right now?
It's mostly for repeatability reasons. So because next time nobody knows what radius you will measure. The height is probably not so important, but the radius is mostly important. This will make a big difference, especially in a.
Okay, I see. Yes, that would be the case when we would have another part. Yes.
Yes.
Okay, but in our let's say in our
for a single measurement, you should know what you want to know.
Exactly. So now I could initiate the measurement.
Yeah. This is for probably the reason why you have this. I call it simple machine, because most industrial they have us programming it, and they want to have complete families with barcode scanner and so on, with statistic export. And I don't know.
Yes. I would say it's really good. It is, again, it is too micro.
That's fine. Yeah, I also think so.
Yes. So add the multi-feature.
Good. Now we can save it if you want to replay it.
There the directions on the scales. I mean, especially with a Z.
Yeah.
Let's say up and down. It's kind of hard to remember because my instinct would be that clockwise is down. But oh yes, it was that. Yes. So counterclockwise. Sorry, I meant other way. So counterclockwise is up. Yes. I meant clockwise, up and etc. But
yeah, but okay.
Yes. So multi-feature selection. I mean, this is done. There is nothing else we can measure here.
Yeah. So if you had the multi-feature, then the only thing you can do now is just have a look for things like the report.
Oh yes, let's do it.
Yeah. So if you just see the multi-feature, I think this is one early version. Yeah. So the
Print.
I think
Perhaps.
huh?
Print.
Yeah, if you just go inside one of these measurements, edit perpendicularity, for example.
Okay.
So and then for the result, you can select what is to print automatically, save to. I don't know. I can't really read.
Let's see what print automatically does, but there is no printer attached anyway. So
yeah. So yeah. But this could be a PDF printer anyway. So something like free PDF XP or something like this.
Results, measurements, no results, nothing seen here.
Yeah.
Let's try to save. No, nothing. Print. Let's see if I press print over there. Select it, show preview. Okay, now it's printing the perpendicularity.
Yeah.
And it printed as a picture, as a JPG.
And the result is in the table below.
Yes. Okay. And this is something we can, at least to some extent, we can modify, I think.
Yeah.
Okay. Quite nice, actually. So it's 3 o'clock here. Let's see. Let's see. What else we could do as we are here? Perhaps, or what would you suggest now? Is there something fundamental we haven't covered yet?
No, I don't think so.
Okay, let's think. Let's have 10 minutes of break and then we will make a decision.
Okay.
Let's think 10 minutes, have a coffee.
Yeah, coffee is good.
And then we will decide what to do next, if anything. Okay. Okay, I mean, one thing we were thinking now on this object, on this part, would be how to evaluate the flatness of this surface, for instance.
Yeah.
So we have measured we have measured the perpendicularity.
Yeah.
In principle, we could reuse this one.
Yeah, that's right.
But the question is, let's say hypothetically, can we make the measurement more accurate if we do another measurement on another diameter? We move the probe a little bit.
Could be. Yeah, let's just try it. So I'm not sure exactly. So the problem is that the software version you have there is really old. Yeah. So it's about I guess 12 or 14 years old.
Yes. The system was bought 2007. I wasn't even working then here.
Yeah. Okay. That's 15 years. Yeah. Perfect. Good guessing. Yeah, and that's the problem. I don't know exactly what is supported and what is not, but it's worth trying it. So
okay, let's from selection we take flatness.
Yeah.
We take flatness measure, and is it now possible that I can reuse and I can also add a measurement?
No. This is unfortunately this is not possible.
Okay, So I have to do either one. But
Yeah.
now if I choose measurement, okay, let's try to do measurement. Let's try to measurement. Let's call it whatever. And here I see that there is this a number of measurements is inactive. Does it mean that?
And this is a hint that only one circle is possible.
Okay, so in right now it actually wouldn't. I mean, we can do either two of things. We can reuse the one we made previously, or we can make a new measurement.
That's right.
Okay. Anyway, I think it is. I would like to think that we know how to do it.
Okay, that's what I also think until now. So I'm pretty sure you can operate the machine.
Yes. Okay. What else? What else we can think about? The only other question I have would be that, for instance, once there was a part where we, you remember when we did this one, the probe was touching like this direction. Yes.
Yeah. Yeah.
Let's say if you have a situation where we need to measure in the opposite direction for some reason, is it logical?
Yeah, that's possible. Yeah, that's quite common, especially if you have a bigger diameter. You have to do this because you cannot overrun the z-axis more than a few millimeters.
Okay, so just hypothetically, let's go through this. So let's say I would try to measure roundness on this situation, and now obviously I would need to change the probe direction.
Yes. Okay.
Okay, to do that I would need to go to measuring station.
Yes.
I will put it. I can't go to minus. No.
No, but you can go to 0. That's enough.
Let's say we go to 0.
Yeah.
Okay.
The reason why we usually measure at at 7 or 10 degrees is that we just have expecting to have a long cylinder just passing by the probe. But in case we measure internally, the limit is anyway the probe length.
Okay. Yes.
So then we can also measure in both directions at 0 degrees. This would be possible.
So let's turn it physically to 0.
Yeah.
And now it is 0. And the measuring direction is actually correct.
Yes, because we already measured down before.
Exactly. So yes.
Yeah.
Yes.
Yeah.
And actually there is nothing to it. Now it should be all set.
Yes, and now we could measure.
Now we could measure, and that is that. Yes.
That's it. So.
Okay. And if I would need to change it, then I would need to use these two buttons.
Yes.
Actually, I mean, the vector below here is quite useful because this is showing which.
Yeah.
Yeah. Okay. Well, let me ask you, what is this set probe arm to 0? What are these two buttons, if you see them?
So usually, in case of you press this button, then the machine will ask you to move the probe until the deviation is 0. So at the moment we have a pre-deviation of the probe of 1 millimeter. You see the red button. Yeah, and if you press this one, the machine will ask you to contact the part until the deviation of the probe is 0.
And why would I need to do that?
To contact the part.
Ah, okay, okay. So this is a kind of feature, so you can be sure that you are in contact with the surface.
Yes. And mainly these two buttons are mainly for the automatic machine where the contact is done with the motoric axis.
Okay, so not important, not
important for you.
Okay, but anyway, as we are still here, so perhaps just let's go through these tabs.
Yes. Yeah.
The buttons over here, the stop and these, what are those?
The first is stop is if you have a complete measuring set running, then you can stop the program.
Okay.
Yeah, in this case, it's still saying stop because we are just in kind of programming mode of the. So if you press stop, probably it would just break the programming mode and will return to something. I don't know.
Okay. So it is, again, something more related to CNC machines.
That's right. The next one is just moving to the reference points. Just if you click on it, you will get the same dialogue like in the beginning.
Okay. Would we need to do something now?
We should now tell the machine where the machine is. So,
Okay,
but it's not exactly necessary. If you just say cancel, it should also work.
Okay. And information is information.
Yeah, information you will get the version and the available licenses and so on.
Close. So let's close measuring station.
So
here we have the selection. There is the position. This is for what?
This is position if you have want to make a complete measurement function, then you have to make something like a safety position in between to swivel the axis and so on.
Again, sounds like something related to CNC machines.
No, this is more if you just have a, let's say, a power user who is able to make the program. And then you have a simple worker just operating usually the manufacturing machines, the turning machine or whatever, who is supposed to just take one of these measurements, start it and follow the instructions.
Okay.
Yeah. Okay. That's there is also, you can see that there is this message text.
Yes, it is.
Yeah, that you could, for example, make explain the purpose why it's supposed to move somewhere.
Okay, then we this we know. Settings we have touched. Measurement, evaluation we have touched. Inclusions, record header. This is something for the protocol.
For the report, yes.
And graph.
Then you can set a scale to a manual scale. Yeah. Okay. And there's always the difference between auto and best fit.
Okay, this we can.
Best fit is something like a scale rate of 2.735. Yeah.
But and sorry, I go to multi-feature. I choose perpendicularity and I edit it.
Yeah.
Okay, it's not here.
No, it's not here. Yeah.
Graph. Oh,
graph. Yes.
Let's try.
So best fit. Yeah. Try. Okay.
It's not working.
No, doch. It is. Just go for result, and it's probably updated. Go for result. Result.
Where?
More up. Yeah. Yeah. Measure. Now result. No result.
No.
And maybe go for the measurement again. So it could be that this is not really updated. Datum. Reuse. Just have a look in the reuse. Reuse.
Okay.
With the changing the reuse.
The measurement, I think.
The measurement was lost.
Let's see. We have the perpendicularity. It's still here.
Yeah. Okay.
It's still here.
And so take something else that is anyway reuse. Yeah, value. Okay, that's it. Yeah, that's good. If you just go for edit. So now we will just go for the yes.
Was it
graph?
Graph, yes.
Yeah, and then best fit. Fit.
Okay,
now apply.
Yes.
We just go for apply, and then we just go in there again. And then you see the scale in the lower left bottom.
Yes.
Edge. What is the scale there?
2 microns.
2 microns still.
Still,
Just
yes.
so just go in again. Maybe it's was not updated.
Settings, was it graph? Let's put 5. Let's see if it works. 5,
Yeah,
fly. It's still 2.
yeah. Okay.
I mean,
And
it's not that important. It didn't change
yeah,
here.
but select some different task and go in again. So
Coaxial.
yeah, and switch back to round. Maybe the picture is not updated.
No,
No.
it is still 2. Yes.
Yeah. Okay. Then could be.
Okay, that is honestly, it is
Yeah.
at the moment, it is not of any importance.
Yeah.
Okay, so I don't know. Perhaps the students, now it's your turn
Mhm.
to give out your opinion, please, if you like. I have to say, the ones who were here, they are gone. Yes. I see there are some still online,
Yeah.
but if no questions, I would say we are done for today. The only thing I would ask you would be, I mean, you suggested us the use of the app. Perhaps there are some other good learning materials on the subject you would
Yeah.
recommend from the Mars side.
Yeah.
Please, we would be thankful if you could share the information, send me an email, for example.
The only thing I could do is something like sending you the information that is written on this app as a big sheet to put at the wall at a lab or something like this.
Okay, yes, this is also already good. If you, I don't know, an exercise, something like an exercise book or manual. Of course, I was able to find a manual for this machine too, but
yeah. Can you tell me the exact version of your software? What is the version?
I should be able to see it from the help menu, perhaps.
Yeah, the help menu or the
Info.
measuring station. There
Measuring
should be also
station.
info button.
Info button. It is MahrWin 2.04-05 SP12 service pack 12, I think.
Okay, yeah, then it's that's our version from 2007, from June 2007.
Okay.
We could think about updating it to the version from 2010, version 2.10.
Okay.
Minus 12.20.
Yes, I don't know if it is. Perhaps, yeah. I mean, is it worth it? It's my question.
The question is, for example, this crash with the procedure. If you ever use this, then it would be worth trying a new version. Maybe this is fixed there,
Okay.
but I don't know.
Let's say functionality wise, I think there is no huge difference, or
no, definitely not as all. Maybe something like with the scale will be working or complete supported. I'm not sure. But
okay.
I'm almost sure that you will have other bugs in there then.
Okay. So a question about this physical chuck that we have here. What kind of solutions you have seen? What would be the recommended? Is it like this, or is there some more universal physical fixtures we can think about?
No. I think this is the best you can get, and you did it yourself. That's not one from MahrMMQ.
Yes.
And the one from MahrMMQ is, I think, really expensive. As long as you can just clamp everything you have there, I don't see a reason why you should use something different.
There is this one question I have been wondering. You see that there seems to be a kind of a reference mark
Yeah.
on
This
this,
is,
and there is also this 135 degrees.
yes.
What is the significance, or what do they have any meaning?
This is just a mark for the alignment of the table when mounting it, that during the centering and tilting process, the machine is turning the X and Y or A and B axis to you, that you can easily manipulate them.
Okay, okay.
And if the table is mounted in a other position, then this won't work. So then the knobs would be somewhere else.
Okay, okay. Okay, I have a feeling that we are done for today. I
That's
don't
good.
see any activity from the students. So I think from now, from this point on, it's up to us to start using the machine more intensively.
Yeah. So, and if you have questions, then just let me know, make a description, send some pictures, and then I will just be able to give you some support.
Okay. I mean, just minor third, because I mean, at one point, I would need to check this part. This check, and especially this. Let's say this bottom one would be the reference plane.
Yeah. Then I definitely would not mount it there. So just mount it with the screw from the other side.
But I mean, this is okay. Let's go through this hypothetically. To have a datum plane, then I would need to use this bottom.
Just check if this one is just fitting to the thread on the part that is actually in. Is this the right diameter?
Yes, actually it should be. You are so right.
Yeah, then just see if it's fitting.
Let's see.
No, it's just leave it in. On the opposite side.
Oh, you see, you are correct.
Yeah. So
because, I mean, these come from the same machine, so that's logical. Yes.
Yeah.
So, but now again we have the problem with no, we don't. So let's do this measurement. We can actually set this surface.
Yes.
As a reference, and let's try to evaluate what we can evaluate. If this is reference.
Yes, but probably I would just mount the part other way around. If the thread is just going through, then I would mount the part other way around, because it's easier to access.
So let's say you mean like this?
This way, yes.
But okay, but I started to think, let's say I will, now it is okay.
Yeah.
So what kind of measurements we can do if we set this now as a reference plane? What are the features? What are the geometrical features that have reference to a plane that we can check? Now,
perpendicularity also in this case. So you can make a perpendicularity to an axis, with a plane to an axis, or other way around. This is no problem.
Okay, so we can take this plane as a datum plane.
Yes.
We can measure the axis, let's say, of these two diameters.
Yes.
And we can evaluate the perpendicularity of the axis.
Yeah.
To this plane.
Yeah.
Okay, but correct me if I'm wrong. Let's say if let's call it the client, it is our colleague, so to say, who is building this.
Yeah.
If he says that he has a problem with this surface, I mean, this surface is kind of wobbling.
Yeah.
What would am I thinking in the right direction? Do we get anything from referencing to this plane with the problem of this surface?
The problem is for me always to understand what is the usage of the part, how it is really used. And so I usually go from the mounting or the reference, which will create some kind of base for this part. So for example, you have a bolt in there with a screw, and this screw is going down on the opposite side, down. So just turn around. So yeah, it's going in there.
Yes.
So yeah, and then you have the workpiece, or this part is just connected to the bolt inside by the thread, but the alignment of this thread is, if it's short enough, it's more the plane beside this thread than the thread itself.
Okay. Okay.
Yeah. So this is the point, and that's why it's sometimes more significant to measure these as in assembled stadium.
Okay, so I see. Okay.
Yeah.
Meanwhile, I think I now remember our discussion. Our discussion with my colleague was that this again is made by us, by
Yes.
students.
Yeah, of course.
So I think that our discussion was on the subject that he claimed that these surfaces are not parallel, and now we can actually measure it. We take this as a reference because it is clamped down, or it is holding on this surface.
Yeah.
And if, I mean, his claim was that if they are not parallel, that's why the upper surface starts wobbling when it is around.
Yeah. That's okay.
Okay, so let's do it. I will fold it down.
Yeah.
Like this. Let's say it's now fixed.
Yeah, fixed. Yeah.
It's now fixed, and do we now need to again center it, or it shouldn't matter?
I guess it's probably not a big deal to not center it, because we just probably are still in measuring range for measuring range 2.
Okay.
I assume. So and that's why I would go directly with measuring the plane of both sides, and then we can just select one as a reference for the other one.
Okay, so let's do it.
Yeah.
To do that, I can either use the datum plane or I can use flatness. Is it so?
I would probably go for measuring 2 times flatness and re-evaluate the parallelity later on.
I will call it flatness down.
Yeah.
Flatness down, the first one. That is okay. Let me see that this is all okay. This one, this button over there.
Yes.
We would need to change the measuring direction.
Yes, that's right.
This I would need to change.
Yeah.
Everything else is okay.
Yeah.
No. I would need to go to measuring station and control probe, put it to 90 degrees.
Yes.
Now physically turn it to 90 degrees.
Yeah, if hopefully we can pass by the part, because we need to end up underneath.
Yes, we can. That is.
We can. Good.
Yes. We can. Yes. Then we can. I will put it okay.
Yeah.
The measuring force is incorrect.
Incorrect.
Change it to 1. Oh, sorry. That was, I need to do it with a knob first.
Post. No, this is this is not the problem. So just must be the same, whatever is coming first.
So now it's correct. This is up. Z is up. This is also there. The measuring range, everything is over there. I can now, the measuring station I will close. I'm back in my measuring task.
Yes.
And I can, in principle, I can start measuring. Let's see. There is this. There are the holes, so that I don't touch the holes. It should be okay. Let's go into contact. let's go into contact with the probe. It's okay, and I can
Okay.
start.
Yes.
It's measuring the flatness. Okay. I mean, yes, the surfaces are not too good, but I mean, it's
Yeah.
okay. It's 2 microns.
Yeah. What I can already see that you see some of these very sharp marks
Yes,
on the that's dust.
absolutely. Yes. Something, some pieces of ships or small pieces.
Yeah, whatever. Yeah.
So this I will add to multi-feature.
Yes.
Now we go back to selection.
Yeah.
Do another flatness.
Yes. Now we changed it to the direction is now correct because that's the default setting.
Yes, it is. Okay, this I did. Yes.
Mhm.
And the probe.
Still has the wrong direction. Mhm.
So I need to go to measuring station.
Yeah, that's not really necessary as long as you don't tell the machine that you already changed the direction. The machine will not recognize. So the machine will ask you now to change it because you programmed that the contact direction is in this direction. So
Okay,
if you just press start,
I will call it
yeah, just to name it up. Yes.
flat up and press start. So it has -1.
Now is coming a question what you wanted to do with the measuring station. So now it's just asking you to do this. So you did already. That's okay. And now you confirm.
Yes.
Now the settings are also done correctly.
So this is set. Now it measures. The flatness, yes. Looks good on this graph. It's not that good, but again, some peaks. I mean, it's
but this is it's just below 5 micrometers. This is not so bad. Yeah. Okay. Add to match.
Yes.
So now we will just go. We create a reference plane.
Datum plane.
Yes, we datum.
We'll just put ref.
Yeah, but which one? Down or up?
I just named it. But
yeah. Okay.
Now I will go and reuse.
Yes.
Reuse and take flat down.
Yes. Okay.
Actually, flat up is what we want to have a reference.
Okay, then just take flat up as reference, as you like.
Yes, flat.
I don't mind. The result shouldn't be a big difference.
Yes, and so just start. Yes.
Yeah.
It's created.
Yeah. So and now you can just go for the selection and make the parallelity.
Parallelism.
Yeah, so now you have to select the right measuring direction. Yeah.
Call it. Sorry, measuring.
No, the measuring direction. So now you are measuring radial, but you want to measure axial.
Oh yes. Parallelism. Okay, this also has a direction. Yes.
Yeah.
Okay. So now we have access to the references.
Yeah.
It should be somewhere. Plane this one.
Yeah.
Add.
So now we go for the reuse.
Reuse, and then we will also flat down.
Down. Yes.
Add and start.
Yeah.
Okay, this is not so cool. It is 0.5 millimeter.
Yeah.
Okay, that is the problem. Yes.
This is the problem. This is what he's just telling. So the surface, each surface is good, but they are not fitting to each other.
Oh yes. Okay. Okay. Yes, I'm having difficulties to admit that someone else was right, but let it be. Yes. Okay. Okay, but that's cool. That's cool. So I mean, we can do the measurement.
Yeah, and now if you know that this is so big, then you can also just take a caliper and measure at
yes.
different sites, and you will get also the difference.
This is exactly what the colleague did. Yes.
Yes.
Measured with the caliper. Yes.
Yeah.
Okay. Okay. Cool. Okay. I mean, yes.
So the problem is probably that the two surfaces are just manufactured in different clamping positions on the machine.
In different setups. Yes.
Yes, and the only thing how they could change it is if they would actually manufacture the inside thread first,
Okay.
then mount it to I don't know, axis, clamp the axis, and manufacturing outside afterwards in once.
Okay.
Then it's probably perfect.
Oh yes, yes, yes. Very cool. Yes.
So
okay, I say we because no other ideas from my side.
okay, that's fine.
One.
Good.
Okay.
So maybe next year, same again.
Who knows? We have a same bunch of students, but let's say right now we have the material, and then we should be able to use this material already.
Okay.
Yes. Okay. Anyway, thank you very much. I would say right now it was a pleasure.
Yeah. You're welcome.
I'm quite sure that the students also liked it, at least the ones who were here. The ones online are doing who knows what.
Yeah, I hope so that they will get the chance to practice a little bit on the machine because this is a very important to fix this inside your brain, and just the best way to get some new stuff is get it with your fingers. Yeah,
that is so true. Yes, that is so true.
Yeah.
Okay, so so we leave it here. Okay.
Okay. Have a nice weekend.
Yes,
and fun with the machine.
Okay.
Bye-bye.
Bye.